Why always matter?
Is it new song day, or are you gonna save it?
I'm waiting for the video. I can't play the new one. Oh. Buster, true level.
Yes, this is basic geometry.
I'll put in
Your
it.
flat Earth geometry. Flat Earth geometry. This is basic geometry.
It is.
I called you a flat earther,
My name's Ramsey.
insisting that your flat Earth geometry will work.
I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad, naked caveman eyeball in a bubble of air, you're the reason this species is a failure, and it makes me angry.
Did he say a five-sided square, question mark?
You're a universal horizontal waterer.
You're drunk.
I called you a flat earther.
You want to experience true level? Do you? Yes. You want to experience true level?
That auto level is establishing a horizontal. That's just the way it is.
Because I've done the test with an auto level, which gives you a horizontal.
Yeah, it's gonna look super flat.
All right, come on. Wow, it's so.
Three coplanar points.
Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
If you're into math, there's a certain shape where you could make a five-sided square.
Are you suggesting that horizontal can't curve?
Oh, everything's crooked. Reality is poison. I want to go back. I hate this.
What's his deal?
Shh. Morty. You go to school, Summer. I'll go in Morty's memory and do a little.
Ranty, come on, that's a globe. And he eventually just gave up and said, yeah, I agree, it's a globe.
Geodesic is a continuous string of infinitely small, straight lines.
Yeah, true level, bitch.
It's really flat and level now.
Ranty, come on, that's a globe.
Yeah, true level, bitch.
Ranty, come on, that's a globe.
Lance to the cosmic slaughter! Well? You seem to be in charge of what I get to remember. Why? Good question.
Ranty, come on, that's a globe.
I'll go in Morty's memory and do a little. Wow, it's so. Oh my God! Oh Christ! Yeah, true level, bitch.
If you're into math, there's a certain shape where you could make a five-sided square.
Ranty, come on, that's a globe.
Yeah, true level, bitch. Wow, it's so. Oh my God! Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
Yeah, true level, bitch.
Person to think.
When you get to the end of this test and you have a result and you say level is horizontal and everyone says big whoop, that doesn't prove anything about the shape of the earth, will you then say yes it does?
No.
No, okay, I'm going to bed. Alright.
Okay, so
I'm going to bed.
that level is horizontal is good for you then, right?
I agree level's horizontal.
Sweet.
True level, bitch.
Perfect.
Wow.
Nice, mate. I came
Nice.
in just for that. You flipped it, man.
Yeah, true level, bitch.
And we are live. Welcome everybody. It's Wednesday, Hump Day, or maybe not Hump Day, just Wednesday. We're not going to be doing the trivium, so if you've been looking in for the trivium, we constantly do that sort of thing, but this is not focused directly on trivium. This is part of Surveyor Fortnight, may even be extended to Surveyor Month. Who knows? Depends how well we go. So today, it being Hump Day and us going over surveying, we sort of go over some of the established facts. Now, as far as I'm aware, I'm the only person within this arena that has a land surveying qualification of any sort. I have a really basic one that we happened to do as I was doing my building construction course when I was at college quite a long time ago. But as we were doing that, I did a specific land surveying, what back in the day was called like an O-level. GCSE. Just, so it's, yeah, I've got a surveying qualification. But most people, there's no point me saying, oh, I'm the authority on it, because that doesn't make it so. The only thing that makes it so is the geometric principles that are behind the procedures that go forward for doing surveying. And since we've been trying to go over the geometric principles, and some people don't seem to think those apply because there are shadow giants that say otherwise. Stupid claims about, well, I don't know. They sort of have a claim that it's not something, but then can't specifically put the finger on what it is, only that it is not something else. Which is I think it's a mental state that you have to put yourself in. We did have Ruhif come in earlier this morning because he said he was bored. I'll probably put that out as a 20-minute clip, but it does go to show that the Elenchus, the procedure of asking people questions for clarification of a claim that they've made, is hard for people to deal with. We have had Alfag in earlier today as well, and he expressed his dislike to the Elenchus by purely just not answering questions, going quiet, disappearing, eventually leaving, much like Ruhif did. Nobody seems to be able to state even what their argument is against simple geometric facts that we state. And we can clarify as well if anybody wants to ask us. Up for that. And we can clarify it geometrically as specifically as possible. Geometry does give you a chance to do that. So I'd say anybody, if you want to come in, discuss any of this stuff that we're going over. What we are going to be going over is 2 videos from a guy called the Illinois Surveyor. Now, this guy he's just a random guy, but he has a real easy way to describe exactly how this process would go about. It's one of those things that where you think we could do with making a video. I'll go and have a look. Oh, it's already been done. This guy has done it perfectly. Doesn't really need any more clarification from anybody to make a video on this particular topic. So yeah, if anybody's got any ideas on how you would measure at either a hump or a drop of the water level. But bear in mind the stolen concept fallacy. You can't use something to try and disprove the something that you're using. Remember that, because that's going to be one of the big fallacies that occur. Right, let me see if I can get these videos. Anybody got anything they want to chat about? Well, I'm finding this stuff. Oh, wait a minute. Oh, everybody was chatting earlier. It was all going. Now we go live. Right. Think I'm ready to go over these videos. As long as I can sort this out. Right, that's better. Right. Sorry about that. Many screens. So, this being Surveyor Week, and what we're going to be talking about specifically here is surveying procedure and a surveyor's idea of leveling. One video is 7 minutes. I think the second one's 9 minutes long. So, right, Illinois surveyor. Sub to this guy. He's pretty good if you're struggling to know about this. Right, so here we go. Anybody else? That was stop.
The contour lines on topographic maps like this one indicate slope and elevation. In this 5-part video series, we'll explore the tools and methods used to determine elevation. I'm Todd Horton for the Illinois Professional Land Surveyors Association.
Okay, so first off, contour lines on the map. And he's going to go and tell you how to measure elevation. Dead confident about it as well, isn't he?
A mapping survey collects the information we need to make maps. Maps can be enormously valuable for decision making. For example, in modern agriculture, we can use maps to analyze the shape of the land surface and to plan drain tile systems like you see here. We pay close attention to surface slope to produce efficient, reliable systems. You learned that slope is a ratio of rise over run. Rise is a change in elevation, that is a vertical distance, and run is a horizontal distance. Measuring horizontal distance is simple with a tape or with a measuring wheel. But how can we measure the vertical distance? That is, the rise between the points shown here. Well, that vertical distance is best found by a process we call leveling. To most people, this is a level. More specifically, this is a carpenter level. It has a bubble tube that indicates which end of the level is higher than the other. Well, how does it do that? You see, the bubble moves in a curved tube like you see here. That's a very flat curvature. As the tube tilts, the buoyant bubble rises to the highest possible position within the tube. Now, if I can hold the carpenter level steady with the bubble centered within the marks, both ends of the level will have the same elevation. Here you can see that the concrete surface at this end is higher than the concrete surface at the other end of the level. The underside of the level is now a reference line we can use. With the bubble centered within the marks, I can measure down from the underside of the level to the concrete. This measurement is 0.18 feet. Since the other end of the level sits on the concrete, the vertical distance between the two ends is 0.18 feet. By repeating this process over and over, adding measurements end to end, we could find the vertical distance between two distant points. But that becomes very impractical as the horizontal distance increases. So, instead, for leveling surveys, we use instruments like these. This is an optical level. It's basically a telescope that can be oriented to create a horizontal or level line of sight.
Okay, pause it for a second there. This guy just speaking basic truths, and he definitely is equating level and horizontal as the same thing. There's no difference. And he's just talking about vertical as referenced to the level line, straight line, or horizontal. It's obvious, this is... It's obvious truth. Everybody knows this. And doesn't he do it well?
I'm watching, mate.
Yeah.
Yeah. It's nicely done.
Yeah.
Simple.
But yeah, this guy, although he's speaking basic stuff, he speaks of it very well, very clear, and it's very easy to understand. Do you want us to rewind that a bit, Rob? I'll just rewind that last bit. Talking about level.
Horizontal distance increases. So, instead, for leveling surveys, we use instruments like these. This is an optical level. It's basically a telescope that can be oriented to create a horizontal or level line of sight. Well, how does that work? The level telescope contains a crosshair. The horizontal crosshair defines a level plane in all directions. That is, your line of sight through the horizontal crosshair is a level line, perpendicular to gravity. Just like the underside of the carpenter level was held level just a few moments ago, now your line of sight is level. Because the optical level is telescopic, you can see farther. If you can see farther, then the distance between your measured locations can grow. To measure elevation difference with an optical level, we also need a level rod. This one is graduated in decimal feet upward from 0 at the bottom. The difference in two rod readings taken from the same instrument location equals the elevation difference.
Now here are some examples of optical levels. This dumpy level was made around 1915. Notice how long the telescope is. Using the 4 adjusting screws in the instrument base, a surveyor would level the instrument in 2 directions, centering the bubble in its cylindrical tube.
The tilting level represented the next generation of leveling precision. This one was manufactured in the 1940s. As optical science had improved, it sported a shorter telescope, and it had an innovative feature that allowed more precise leveling: the split bubble. Below the long bubble tube, an adjustable mirror reflects light into the fluid and bubble in the cylindrical tube. Using a separate eyepiece and another internal mirror, the operator views two halves of the bubble image and adjusts the level carefully to align the two images. Introduced in the 1950s, the automatic level contains a set of tiny mirrors that move automatically in response to Earth gravity, ensuring that the instrument line of sight is perfectly level. If the instrument settles during use, this automatic compensator simultaneously adjusts the line of sight back to the horizontal plane. Here you can see the top of the mechanism moving as the instrument is tilted. Because they contain compensators, automatic levels can give greater precision than older uncompensated instruments can. With the advent of inexpensive laser devices, the rotary laser level has made some leveling surveys possible with only a single surveyor. A revolving mirror produces a horizontal plane of laser light. A laser detector on a special leveling rod enables measurement at each desired location. Farm drain tile installation equipment commonly uses a laser plane to control the pipe depth, ensuring proper slopes and efficient drainage.
Yeah, go on. Go ahead.
Yeah, the build that I'm on at the minute, where we're doing the footings, the lady actually is the designer of the house, and she's actually doing the job. And she's a lot of timber that's going to be. It's a timber frame, and she's been like really on our case about, are you going to be able to get in that tolerance? It has to be like perfect, because this carpenter she's got is a specialist carpenter, and he wants it like, he doesn't want to use packers, put it that way.
Yeah.
Right. And we're using a rotary laser. That's what we're using at the moment.
Yeah.
So it's about 20 meters long, and it's probably, I think it's 8 meters wide. And so yeah, it's got to be within that tolerance. I mean, I've said we'll try and hit 0, all the way around. But yeah, it's that's what we're using. That exact, a rotary laser with the receiver.
Yeah, I have to point out that Eric in the chat is saying, when the guy says gravity, he just means vertical. He's talking about level being horizontal, and he's saying it aligns with gravity. Well, that's vertical. As we know, a horizontal plane can have perpendiculars to it, which is vertical. If it's aligning the horizontal plane, then he's just talking about vertical. Just strange words that they use. Paralogisms that have been placed there. Just replace it with vertical, and then horizontal makes sense.
Yeah, I mean, I've never heard anyone explain it like that, like he did.
Yeah.
So maybe it's an American thing.
Yeah, you've got to allow for the way people talk.
Yeah. Oh yeah, exactly. Yeah.
So carry on. It's only about a minute.
For high precision, digital levels with advanced internal compensators read the barcode on a special rod while simultaneously collecting atmospheric pressure and temperature readings. Each of these methods creates a horizontal or level line. Using this line, just like we used the underside of the carpenter level, we can find elevation differences, but with a telescope or with a focused beam of laser light, we can extend that line much farther with greater precision.
So far, you've seen the main tools we use for leveling. In the next video, we'll explore the basic processes of a leveling survey. I'm Todd Horton for the Illinois Professional Land Surveyors Association.
Thanks, Todd.
Nice one, Todd.
Yeah. Right.
Don't,
Yeah. Wait a minute, I'll cue this one up. But
I think I see it a long time ago, actually. But
Yeah.
Nice refresher.
Queue up part 2, but I think we'll just go back into Disco for a bit. Before we go on to part 2, because obviously that's needs to be talked about. Right? I mean, it's...
Oh, yeah, the levels that he uses in the beginning, the 4-foot levels.
Yeah.
And he's put it on the floor, and he's and you can screw in and get that on a bit of wood or something, and you swap it around each time.
Yeah.
It's like so you compensate for any, if there is any. I mean, it is bang on. I mean, you wouldn't use a level that isn't level, right? So you're trying to find a slope, and what you don't want is anything. You want that bubble right in the middle. It can't be anything else. And he's trying to create a horizontal. Yeah, we do it all the time.
Yeah, he just shows that what most people think of the bubble level, which he is right? How many times have we been talking to people about a level and they think bubble level? It's just natural. That's what people do, and he's just showing you that you can actually use that for doing the job. But I mean, it's not very practical. But I mean, it's the same thing. It does the same job as that.
Leveling,
yeah. So he's just showing that you do that. But I mean, he does say, like we do, that level is horizontal. Now, I didn't say it because I heard him say it, and he didn't say it because he heard me say it. We both say it because it is.
And I say it.
Yeah.
Because it is.
Provably, like that's the principles, all of the understanding.
Because I know it.
Yeah.
Yeah.
Yeah, not just because I went to college and did surveying, but because everybody, I mean, why would anybody think otherwise? If it's not level, straight, then it's got to be sloped. That's the only other option. And like that guy said, a slope is measured rise over run. Horizontal distance, vertical distance. Very easy.
Yeah, that was nice. That was well explained, yeah.
Yeah, differential leveling next is the actual procedure of how they go about checking elevations and measuring elevation changes. Like he said, it's just a vertical distance from the end of the level. Like it's a difference from one end to the other. Very simple. Nothing complicated about this at all. Establish straight line, horizontal, and measure a vertical distance to the ground. If there's a change, one or the other, if one's greater and one's slow, then that's your vertical change. The horizontal distance is the run and the rise. I think it's he does explain it very well, and I wish I could be more as clear as the way he did that. That's why I can't be. There's no point me making a video because I don't think I could do it as good as that anyway. To explain it. And if I make a video doing that, there's a group of people who'll just say it's not that.
I wish from Globers to make such a video about globe surveying.
Yeah. I don't know. We might have one in here. Jesse's come and joined us. Welcome, Jesse.
Thank you.
Did you watch any of that? Did you hear the surveyor then? The Illinois surveyor, Todd?
No, I just got here when you guys were just talking about it after the fact, I guess.
Yeah. Well, we have. He just basically said that he equated level and horizontal. So a level is a tool for establishing a horizontal plane, and he talked about the rise over run. The run being a horizontal distance and the rise being the vertical change, and that change is what they call an elevation change.
Excellent. What was his YouTube handle?
The Illinois Surveyor. He's been around for a bit. I've seen him. We're going over the next one, the part 2. He does a 5-part series. So,
is he a flat earther?
Pardon?
Is he a flat earther?
He's just a surveyor. Like,
oh, okay.
Oh, why? Why'd you say that?
Well, I've just never spoken to one, and since you had featured him here, I thought he might have been one. I just didn't know, so I asked.
I don't know.
I think that he is speaking on behalf of some surveying association.
Yeah, the Illinois Surveyors. Yeah.
Okay, cool.
But you do realise that there's no. I don't think there's any flat earthers in here. I think Rob might be listening on the in the YouTube. Shout out, Rob. But yeah, there's nothing to do with flat Earth here. This is just about basic geometric concepts.
Oh, okay. Montreal's here.
Yeah, SE's here quite a lot.
Lemon's here.
Yeah, Lemon's here quite a lot as well. It's all right. You don't have anything wrong with them, do you?
Goodness, no. You said there was no flat earthers here. And
yeah, SE. Well, I don't know. Lemon, are you a flat earther?
I would have to go with it being flat, yes. Based off the laser test.
Yeah, Lemon's here. Yeah. See, we've had this thing.
The Earth is demonstrably flat.
But it's demonstrably not flat, as we're going to go over with surveying now, right? Elevation changes.
As a general description of the general layout, it appears to be flat.
Yep. Contradictory earther. Yep, we know. So when Lemon says is flat earther, that means he knows it's not flat. So is
that's the general layout.
Yeah.
Flat. You have to use general descriptors to get at the overall reality. Otherwise, you can't even talk about the thing.
Yeah, well,
as a general descriptor, the Earth would be more accurately a irregular topographical plane, aka flat, with mountains, valleys, and stuff like that.
Not flat. Yeah. I know.
So we're going to say what it isn't, but not what it is. Isn't that kind of contradictory? If we can say what it is not, can't we just as easily say what it is, aka an irregular topographical plane?
It's not flat. All right, can we go on now? Because if it were flat, we would not be able to measure elevation changes, right? And we can measure elevation changes, so therefore it proves it's not flat. Now we're going to carry on.
That's why we use that as a general descriptor.
Well, generally not flat would be my descriptor, denoted by elevation changes. Okay.
Saying what a thing is not very attractive. I could say that you're not a criminal, that you're not a pedophile, that you're not a thief, but that's not going to say what you are. I would need a general descriptor to encapsulate that of some sort. And for the Earth, it's flat.
Okay, right. Okay. Well, when we said earlier, Jesse, that there are no flat earthers in here, obviously Lemon's now come in and obfuscated and proved to everybody what a contradictory position a flat earther has to take. Now, other than Lemon, I don't think there's anybody else that would say what Lemon says. So
I'm here now.
Lemon's
But
on.
even then, you use the general descriptor for the room without getting bogged down into the minutia and the specifics. Translating that to the shape of the Earth, the general overall shape appears to be flat, with hills and valleys and topographical differences, sure, okay. But you can still say, with a fair amount of accuracy and generality, that it's flat.
Yeah. All right. Well, we're not flat earthers here, Lemon. And I think the position you take, personally, is fucking ridiculous. So that's why I say, you know, in order for you to be a flat earther, you have to say, you know, it's not flat, but therefore you have to generalize a not flat into being flat, which is ridiculous.
Well, if water is flat and water is contained, then the container for the water would tend to be flattish. Even if it's more accurately described as a shallow ocean basin for the actual shape of the Earth, sure. But that ocean basin to contain the water would tend to be flat. Otherwise, how could it contain the flat water? As a general descriptor, it's good enough.
Okay. So do you think that you can measure elevation changes?
You would measure elevation changes relative to a flat baseline, like flat contained water. Yes.
Like a horizontal plane, like the surveyor just said.
You could draw an imaginary flat line in the middle of the air like the surveyor tries to, and or assume that water is a flat plane that you measure off of.
You know, when you just said then, did you say flat line?
Yes.
That show that you're flat obsessed, right? Because I'd just call it a straight line. I don't think you can have a flat line. Just shows how your thinking's going.
If the line isn't flat, then how do you know that it's straight?
A straight line being the shortest distance between 2 points. You would know it's straight because it's the shortest distance between 2 points. It would just mean straight.
But
like, do you not?
We need to derive some sort of implication off of that for this argument to go anywhere. And the implication is that it's going straight from point A to point B because it is flat and level without curving or deviating. One would tend to assume.
Yeah, a horizontal plane, Lemon. Right? Regardless of anything to do with the Earth or your obsession with flat or your generalization of flat, we're just talking about a horizontal plane. And a tool that does that, you know, establishes that. Called a level. They're very simple. But this tool measures elevation changes specifically. Those elevation changes show it's not flat.
Well, in that case, we need to determine if it's a flat level or a curved level. A flat straight line or a curved straight line, then.
What, the horizontal plane? Are you questioning a horizontal plane, Lemon?
No, I'm just declaring the obvious inference that can be made from a, line going straight, and that it's probably more or less flat. It's not curving. Otherwise, how can it go straight from point A to point B if it's curving all over the place? It's contradictory.
Yep. Okay. Are you ready now to go into stage 2 of leveling, differential leveling? Or would you like to try and obfuscate something for somebody?
Why do you say that I'm obfuscating? I'm trying to take the obvious implications and take them to an obvious, logical, necessary conclusion.
And I'm just pointing out that these tools called levels measure elevation changes. Those elevation changes prove it's not flat. I know that
relative
upsets
to
you.
what
I know
baseline
you've got your obsession, and a
relative
proof
to the
against
baseline of
that
flat water.
is upsetting
And
for
when
you.
we carry this out to its logical conclusion, if its elevation changes relative to flat level water and the water is contained and flat, well, then it would have to be contained by something else that's at least flattish, aka a flat Earth. Now, if the water is not contained and we're dealing
Lemon.
with iceberg Earth, okay, maybe. But the moment that water is contained,
Are
and the
you
moment the
are you
land doesn't go
fighting for
too
flat
far
Earth,
above
knowing
that
that
zone of
there are
containment,
elevation
it's
changes?
going to be
It's fucking
deemed more or
ridiculous.
less flat. That's just the necessary inference.
You are obsessed, Lemon. But
What are you talking about?
thanks
I'm
for
just
showing
taking
Jesse.
something to a logical
Thanks for
conclusion.
showing Jesse.
Are you calling obsession taking things to a logical conclusion?
I'm
so that
talking
people
an
can go
obsession
somewhere?
about you with flat. So much so that
Okay,
you're
I guess
calling
by
a
that metric, I'm
line
flat upset.
flat.
It just seems like you're not making necessary conclusions. You're avoiding making
I'm not
necessary
making
conclusions
necessary
in a way that's a
conclusions.
little questionable.
What's
it's a
the
little
necessary
dishonest.
conclusion, Lemon? That flat
The
isn't
necessary
flat.
conclusion is that the Earth is more or less flat.
It's
if
not
it is
flat though
containing
if you
flat
can
water.
measure elevation changes. It's fucking ridiculous, Lemon.
Okay, so then you need to prove that the water isn't contained and we have iceberg Earth or something like that. Because the moment we say that the water on the Earth is contained and it is flat, that's going to tend to make the Earth somewhat flat.
We don't talk about that.
I mean, you can avoid the conclusions as much as you want to say what the Earth is not, but good logic that actually leads to where it leads to a logical, necessary conclusion so that we can establish other premises based off of it and go somewhere. Otherwise, we're just going to sit around saying what the Earth is not all freaking day.
Yep. It's definitely not flat.
Flat-ish.
One thing I can be absolutely certain of, it's not flat.
Okay, I'll settle for flat-ish. How about that?
Yeah, as you can see, Jesse, have you never talked to a flat earther? Because they're full on.
I've actually debated both Lemon and Montreal on Jose's show.
You've debated?
Yeah, on Jose's live show.
A debate? Wow.
Well, you know, they yell everyone yells at each other. I don't know if it's a debate, but it's live, and it's on Discord and on YouTube.
Okay. Right, well, I don't think SE's a flat earther, but...
Have you changed your name, Jesse?
Nope.
I'm trying to remember if we had a conversation, but I don't seem to recall. Must have been a while ago.
Well, you sound like the same guy that used to go to Jose's live show.
That was a couple of years ago, yeah.
Has it been 2 years? Wow.
I would say, yeah, around there. So you're of the round.
Oh,
You're
no.
Earth?
Let's not do that. We want to get through the surveying and go over how actual surveyors work, and then we can get on to Jesse's stuff. But I'd just like to say in the chat we've got FE Reality Denial Club that says it isn't flat on average either. It's virtually a perfect sphere. Virtually.
Isn't it pear-shaped?
He says it's virtually a perfect sphere. Virtually. Which I don't know. It's the same as virtually flat. Generally flat. I mean, I don't know.
I've heard pears.
Yeah.
Balls, pool balls. You know, you hear all kinds of weird things, different things.
Yeah, slightly chubbier. I think I've heard used by a couple of people. Slightly chubbier.
Shut up, Neil.
And blue. And blue.
Yeah.
Right. Okay. Video number 2. This one's a little bit longer, maybe a little bit more technical. Again, if anybody wants to stop us about anything, but we'll talk about it in a bit.
Equipped with a leveling rod and an instrument, we can measure elevation differences. In this video, we'll explore the basic field processes involved in measuring those differences and then computing elevations. I'm Todd Horton for the Illinois Professional Land Surveyors Association.
Using an optical level, we create a horizontal line of sight. Where our line of sight intersects the level rod, we take rod readings. With these rod readings, we can compute elevation differences. With practice, most instrument operators can confidently read the rod when it is 250 feet away. Thus, if I need to find the rise between two locations 500 feet apart, I simply set up halfway between the points and take 2 readings. But what if I can't see between those points? For instance, in this scenario, the elevation difference is greater than the height of my tripod. Or what if the locations are 5,000 feet apart? Well, to overcome these obstacles, we perform a level circuit. We perform a level circuit by measuring a series of elevation differences end to end. In the first video, we illustrated the concept with the carpenter level, but now we do the same process on a grander scale with an optical level. To find an unknown elevation shown here on the right, we must first start from an elevation that is known, shown here on the left. An elevation is a vertical distance above or below a reference surface. We commonly use mean sea level as a reference surface. For instance, the summit of Mount Everest is 29,029 feet above mean sea level, and the lowest point in the United States is Death Valley at 282 feet below sea level. By measuring vast networks of level circuits across the continent, surveyors have established heights above sea level at stable, permanent benchmarks. Benchmarks come in many forms and are attached to everyday objects like bridges and fire hydrants. Let's walk through a typical level circuit we call benchmark leveling. You may hear this process called differential leveling or control leveling as well. Here, our survey site is 1/2 mile from the nearest benchmark across a shallow valley. We need to determine the elevation of a newly constructed benchmark on the site. Because of the terrain and the distance involved, we'll have to set up the instrument multiple times to measure a series of elevation differences. First, we'll set up our instrument where we can see the rod sitting atop the known benchmark. Our first rod reading is 4.69 feet. Since this reading is taken on a point of known elevation, we call it a backsite, commonly abbreviated as BS. With this first backsite reading and the known elevation of the benchmark, in our case 842.17 feet, we can say the instrument line of height is 4.69 feet above the elevation of 842.17. Thus, the HI of the instrument, commonly abbreviated as HI, is 842.17 feet plus 4.69 feet, which equals 848.86 feet. When the backsite reading is complete, the rod person can move beyond the instrument operator toward the survey site. At a convenient location where the instrument is visible, the rod person will create a turning point. A turning point is a temporary intermediate point in a level circuit that we use like a benchmark. Each turning point must be stable and have a distinct peak or high point on which the rod will rest. Here, the rod person is using a cold chisel driven firmly in the ground. When it is stable, its top can have only one elevation. This concrete curb has high spots that make good turning points. And this sidewalk corner will work too. With the rod person holding the level rod atop turning point 1, labeled here as TP1, the instrument operator can make another rod reading called a foresight, commonly abbreviated as FS. A foresight is a rod reading taken on a point of unknown elevation. We don't yet know the elevation of turning point 1, so the first reading there is a foresight. Our foresight reading at turning point 1 is 6.08 feet. Since we know the HI is 848.86 feet, and since the instrument line of sight is 6.08 feet above turning point 1, we can now compute the elevation there. We'll subtract the foresight reading from the height of instrument. 848.86 feet minus 6.08 feet equals 840.78 feet. Now we know the elevation of turning point 1. Next, in order to extend our circuit toward the new benchmark, the rod person will stay put while the instrument operator moves beyond turning point 1. At a new location where the rod is clearly visible, the instrument operator will set up the instrument and take a new reading on the rod at turning point 1. Now, here's an important question. Will this reading be a backsight or will it be a foresight? Remember, a backsight reading is a reading on a point of known elevation. And a foresight is a reading on a point of unknown elevation. So, which is it in this case? Well, turning point 1 has a known elevation based on our first instrument setup. So, with a backsight reading of 2.95 feet, the instrument has a new HI. That is, the line of sight is 2.95 feet above the turning point 1 elevation of 840.78 feet, giving an HI of 843.73 feet. Now, the rod person can leave turning point 1. Turning points are for short-term temporary use. After reading both a foresight and a backsight on his cold chisel turning point, he can remove it and move beyond the instrument to set a turning point at a convenient location. With a foresight of 7.17 feet, the elevation on turning point 2 will be 836.56 feet. Well, what should happen next? Simple. The process repeats. At each new instrument setup, there will be a new backsight reading and the new HI. At each new instrument setup, the operator will take two readings, a backsight and a foresight. At each turning point, the rod person will hold the rod on the point for two readings, first a foresight and second a backsight. In the field, the rod person and the instrument operator move separately, taking turns and moving forward in a leapfrog pattern. With the final foresight, there are finally enough measurements with which to compute the elevation of the new benchmark. The process is fairly simple, repetitive, and efficient.
So far, you've seen the core concepts. In the next video, I'll show you how to prevent mistakes, how to record your readings, and how to compute with confidence. I'm Todd Horton for the Illinois Professional Land Surveyors Association.
Do you like that? That was good. Yeah, I'll point out one thing here. You see that picture? What is there not in that picture? What can you not see in that picture?
Earth curve.
Hmm. Nah. Well, you can see the land has got a big dip in the middle of it, so there is a curve there, right? So what is there not in that picture? I'll give you a hint. There's no horizontal distance at all.
Yeah.
Nobody has mentioned any horizontal distance when they're talking about this job here that he's talking about.
Well, he did say earlier that he could read the rod at like 250 feet.
Yeah, a good experienced surveyor can read at 250 meters or 250 feet. Just less than 100 meters. Maximum, right? That would be. But there's no horizontal distance there. He's just got the vertical points in order to find the elevation of that end point. Never once did he ever have to measure a horizontal distance. Doesn't come into it. Which, if you imagine that new benchmark was a mile away, and you were taking the words of some shadow giant, he might say that the level drops away from the horizontal at a certain rate. And then that would be a zero elevation change. But there's a computation that this guy didn't talk about at all. Just purely elevation differences in relation to the horizontal plane. But thanks, Todd. That's good. So that's how surveying would be done locally by surveyors, professional surveyors, establishing elevation changes of new benchmarks. So yeah, there we go. So what do you think about that, everyone? Let me get
This
see
is
if
so
I've got...
simple. This is self-explanatory. So nothing to comment on.
That was very good. Very enlightening, shall we say.
Now, that's basically what we've been saying all along. Elevation change measured from that horizontal plane. Yeah, I mean, we've been saying about geometric proofs, horizontals being parallel, and being straight. The tools being called levels that establish horizontal planes, and then you measuring a vertical distance change from that tool. Yeah, we'll go over it again and again for surveying purposes. Somebody was mentioning the globe surveyors. Now, I think we may have one with us. Seems to be deafened at the moment. Jesse Gordon. Are you there, Jesse? Are you listening in on Discord? On the YouTube. I don't know whether Jesse is a surveyor or not, but he's He's the one that we went over a video the other week of the rising horizon. Like rising as in vertically upwards. Hopefully he'll be coming back in a minute. So we can have a look at it and talk over it. I don't know, maybe not. So, I think we would say, from what that guy's just said, that anything seen above the crosshair would have to be a vertical distance above the horizontal set by the tool. Would we not?
It would.
Well, we've got Jesse in here, and Jesse's got a video he's just done recently where he seems to show the horizon being above the crosshairs. And I'll put the
He has
picture
a
up.
surveyor thing.
I don't know.
Isn't that his logo? What does he have there? What is it? A theodolite or auto level thing? What is it?
Yeah, I think so. It's like I don't know whether he is actually a surveyor or not. We'll have a word with him, but we do have his. Let's change the screen. Change the window. This one. So this. This here is. This is Jesse, who we have in. He's joined us tonight. Thanks very much. And this is his video. It's called Water Horizon Above Eye Level from 3 different heights. Density gradient refraction. So above
eye level.
Above. And then he shows here. See?
So I can put my crosshairs right at the top of the water.
This is.
And look at that. It's 3 to 4 arc minutes above eye level. So the water level is appearing 3 to 4 arc minutes above eye level. That's like almost 1/10 of a degree. So that's very interesting. Now, if we were to...
It's very interesting.
Yeah, is that a hump?
Above. Yeah, that may be the location of the hump.
It's gotta be.
Yeah.
Hey, it's hump day. What do you expect?
Yeah. But, yeah. I suppose the hump's got to be somewhere, hasn't it? But aren't you meant to be on it?
Actual hump.
Yeah.
A view of an actual hump. Come on now. This is big stuff.
Yeah.
Depends on the day. I mean, I've been out and looked over ridiculously long distances.
I've never seen it above, though. See, look.
Could have been a tsunami or something.
Level, which is below the surface of the water. See, there's...
See, it's a level below the surface of the water.
Dear. Oh, dear.
Yeah.
He did say it was strange, didn't he? What did he say? So they didn't say strange. He said
Interesting.
Oh, bit surprised by that.
Interesting. Yeah.
But I can see above this water. I can see some mountains. So I am very curious because this level is even below these mountains, and just in the middle of the water.
I would say very interesting indeed.
I would be. Hopefully, he's
Like
going to
it's
come back.
almost like it's pointing down. It looks like it's pointing down, doesn't it? If you, if I was to say, I don't know. That's weird.
I would be asking like we asked George when George was saying that he pictured it. Are you absolutely sure that it was within calibration and all of these sort of things?
Because, definitely. Very important, obviously.
Yeah, it's a measured vertical change above, saying it's higher than the crosshairs.
Above the water as well. Over that looks a long distance.
Yeah.
Yeah, I don't think
that's not 250 yards or 250 feet. Sorry.
No, you're right. I mean, I don't think the instrument's designed to look out on the ocean like that at some unknown distance.
Over water, absolutely. I think they tell you not to do that. So what he's doing here is definitely not a standard practice for any normal surveyor. And he does this. He moves the thing and to different places.
Hopefully he pops in because he was in there a minute ago.
Yeah.
I mean, he's in Discord, isn't he?
Yeah.
What are your thoughts on what we've said? What's been said?
Is it a draw? Is it a hump or is it a rise?
He's deafened, I think, right now.
Yeah, but you could probably hear us on YouTube.
Oh, okay.
Yeah.
Oh, did he resort to chatting? Crap.
Oh, he's only the first time I've seen him.
Yeah, this is the first time he's ever been in.
Yes, he will be nice.
Yeah. But yeah, he measured. He did this. He changed the auto level. Sorry, the is it a total station? Theodolite? I don't know. Maybe a modern Japanese theodolite or something, not an old school traditional theodolite. I don't know what scope he's got on it either. What magnification? And he does it 3 times, and he says that the water, the horizon, is above eye level. He calls it eye level.
What was his height of eye level? I missed that bit, to be honest.
Well, it's just the crosshairs. He just equates the crosshairs to eye level. Yeah. I don't know whether he actually has a measuring rod or whether you have a measuring rod for these ones, because the Illinois surveyor was talking about levels and optical levels. He wasn't talking about theodolites and total stations and stuff. He was just talking about elevation. And there's no way you can adjust the auto level crosshairs up and down. They're always horizontal. You don't get a chance to adjust it like he does.
And there's no he's got no rod obviously in the picture.
Yeah, no.
Oh, there's never a rod in the
There's
picture, is there, generally, in these type of videos.
No, well,
long range optics over water, I mean.
Well, if you set your tool up, you'll want to be doing a 2-peg test, and you need a measuring rod in order to do that, to make sure it's working right. But you never see a measuring rod in. I don't want to call him a globe surveyor, but I mean, it may be.
What was the other guy's name? The other surveyor,
Concave
the
surveyor.
first two videos?
The Illinois surveyor, Todd.
Illinois.
Yeah.
Todd, yeah. So he had he showed the rod, didn't he?
Amiga Genesis, it's this guy. From Jesse, he's been put forward, I think, by Jesse Kozlowski. Favoured of Jesse Kozlowski.
Namesake.
Yeah, he's gone. Jesse's gone. And I don't know whether this Jesse's the new replacement for the Globe Surveyors.
Is Jesse a common name? Or is it rare, rare name?
Pretty rare in the U.S. Not
Oh,
common
so
at
it just
all.
so happens.
It's like spot on. Pretty rare.
Jesse, part of Team Rocket with Pokemon. So maybe of that sort of age, there may be quite a few Jessies. And Jesse Ventura, who can forget about him?
Oh, yeah.
He was surveyor, of course.
Well, yeah. Yeah, I don't even know if Jesse Gordon is actually a surveyor or he's just been handed one of these tools or not, whether it's his or whether it's
like a hobbyist.
Mm-hmm.
Like the other Jesse.
Yeah. Yeah, Slice Barcane said that. Yeah. So,
but when you stopped at certain frames, it was visible that this crosshair were meeting, were in position where this mountain was meeting the water. So it seemed to me rather correct. So
he can adjust it. He can adjust that crosshair because it's one of those tools where you can adjust it.
But it doesn't tell you if it is level. It's just adjustment of crosshair. Yes.
Yeah, hopefully we can get a chance to have a word with Jesse and work out, because it's definitely not an auto level establishing a horizontal plane if you can move it up and down. So I would like to know as well, like you, how we can establish that it is a horizontal plane. I don't know. When we use the tools, like we said before, we do a 2-peg test to make sure that it's still within calibration. It is still a horizontal plane. There's a check that you can do. It's like a logical check using geometric principles. Now, we always did that beforehand, but didn't bother recording it because it's a bit boring. And would be too upsetting for people that, imagine they know about surveying. Like George. But, just look it up. 2-peg test.
His crosshairs were... was it below the waterline as well, yeah? George's.
George did some as well.
Yeah, the Illinois surveyor, tough act to follow, I guess. Jesse had to bail out.
Yeah. He'll still be here. He's listening in. No doubt when he's finished talking in the chat about rifles and stuff, he might be able to come in and talk to us about his whatever his tool is and whether it was calibrated, and how he can sort of explain that the water level in the distance is higher than his crosshairs.
Oh yeah, rifles. Jesse, you're not coming in. You were talking a minute ago, mate.
What's
Yeah, I'm
talking?
interested. The hump, is it a hump? Is it a slope, upward slope?
Or downward slope?
Or the, yeah?
Yeah. Exactly which kind of horizontal is it? Is it a geometric horizontal? Oh, because we've got those as well. For us
Maybe
to
he
go
prefers
over.
a sagitta. We can give him that. Some people don't like to call it hump.
Wow, still with the old school obfuscation tactics. I mean, Bloods, are you? He's sticking. Oh, come on, let's keep him back onto the surveying. Don't be talking to him about rifle scopes and stuff.
Oh, Wally, is he talking about surveying? Is he?
No, Jesse's having a go at doing anything he
I'm
can
not talking to
obfuscate to not come in and talk about his level when we're doing leveling.
Nothing to do with Jesse, mate. Jesse,
Yeah.
can you come in, please, and chat? Hello, Jesse.
Yeah, Wally's even in there talking about stuff. It's hilarious, isn't it?
I mean, Wally, get on, man.
Yeah, yeah.
He's a Wally, but...
Mm-hmm. He wants to
Maybe
come
Alpha will
into...
pop in as well. Alpha and Jesse could maybe explain it together.
Well, Alpha's already done his stint today, hasn't he?
Yeah, like Jesse doesn't. I don't think he realizes.
Yeah. I know. He's not listening in. He's coming here to just obfuscate and coming out Wally in the chat. So we're on about talking to a surveyor or somebody with a surveying tool that supposedly has, it's a bit hard to say measured, but it has put the horizon, the water level in the distance above what he calls eye level. So that is water higher in the distance than your eyes.
So you must be lower than it.
Yeah, you being lower than the water in the distance. There's only a couple of people that have ever said that, and we're lucky enough to have one in tonight, but it appears he's only going to talk in the YouTube chat about trajectory tables for rifles. Is that what you were talking to Wally about, Bloods?
No, he's showing me Jupiter. He took a picture of.
I just put in there that we're
well,
going over it.
On his
We looked at his
guide
video
scope,
and we're going over it. It'd be nice to have a chat with him about it.
on another scope that he's got to get some close-up pictures.
Okay.
He's actually taking some pictures of the planets for a change and stuff, rather than his
I think he's
satellites.
just
or whatever.
realised, so that'd be nice if he
It's
comes
cool.
in.
Oh, welcome back, Jesse.
You hear me?
Yeah,
thank
we
you,
can hear
thank
you.
you.
Yeah, Bloods.
Right.
All right, Jesse.
Yeah, we just went over your video then,
Okay.
Jesse.
Which video was that?
The one where you I hesitate to say measured, but you placed the water level on the horizon above the eye level, you called it.
Oh, you commented on that one, right?
On that video, yeah.
Okay, yes, that video.
Right. So, can we establish some facts first? Because we are going over, it's Surveyor Fortnight here. Are you a surveyor?
No.
Do you have any surveying qualifications?
Goodness, no.
Okay. The tool you used, was that a theodolite?
Yes, actually, it's a total station, which does everything that a total station or a theodolite does. Plus, it also does the EDM.
EDM.
Electronic distance measuring.
Okay. So, did you measure a distance then?
Only to the water surface in some of the cases.
Okay, to the water surface below, or horizontal?
Yeah. Right. So that instrument, it's not like the laser rangefinders that people get for camping and hunting or whatever. This one needs a retro reflector to bounce off of. So obviously I can't measure stuff out in the distance, but I can put my reflector down by the water's edge and bounce off that, and then it tells me the feet difference between the instrument and the reflector in X, Y, and Z, basically.
Okay, so would that be a vertical distance to the water that you're talking about? I mean, there's no way you could measure the distance to the horizon with that tool, is there?
No.
Okay.
Not unless, well, so actually, if I had a reflector that was out at the water level on the apparent horizon, then I could measure to that if it was within a couple thousand feet.
What? Sorry, you could, providing the horizon was within a couple thousand feet, and you could put your reflector there on the apparent position. You say you could measure it.
Then I could measure the distance between the instrument and the reflector.
But without having the reflector there. I mean, do you have a reflector?
Yeah, I do.
Yeah. Okay. Do you have a measuring rod or not? Do you use it just with the reflector?
I just use it with the reflector. Actually, mostly I just use it to measure angles. Once in a while, I pull out the reflector.
Okay. And for calibration, how do you do that?
You mean, so there's a bunch of different calibrations on these kinds of instruments, and I haven't calibrated any of them. The one calibration that everyone says, oh, you probably want to do is to calibrate for the vertical scale so that forward and reverse readings read the same, right? But this is it. This one's within about 11 to 15 arc seconds, and so if I take a forward and a reverse reading and average them, that's just the same number I'd get if I calibrated it and then only took one reading. But if you take two readings, then you don't ever have to question whether that calibration is out.
What about for level? Or horizontal? How would you calibrate that tool to the horizontal? How would you know that?
So I would use a clear rubber tube full of water, and the instrument actually has little, it looks like a plus symbol, a little like a crosshair symbol molded into the sides of it at the optical center, so you can actually tape your little piece of your rubber tube up against there, and you can fill the rubber tube up so the water line comes right to that crosshairs painted to the side or stamped in the side of the instrument, and then you put the other end of the rubber tube out in front and prop it up on a tripod, and you let the bubbles get all out, so you have water at rest in the rubber tube, and then you can measure the angle to the height of the water in the other end of the tube. Does that make sense?
You can measure the angle to the height of the water at the other end. Is that for establishing a horizontal, or?
Yeah, yeah. To check level. You asked about how do I know if the machine's concept of level matches true level, and that's how I would test it.
With a water level?
With water in a tube, yeah.
With a water level, yeah, that's what a water level is, right?
That's what I call it, yeah, water tube level.
Water, we just call it a water level around here.
Yeah, sometimes I just say water level, but there's also like picture, you can see the water, the lake in the background, and people are like, well, what do you mean that it was at the water level? No, the water level's down there. And so I try to distinguish, I'm talking about the water level in the tube. So I say water tube level, that's all.
Okay, now how long would you require that water level to be?
Well, it depends on how much accuracy I need.
Horizontal would be the accuracy. I mean, how long would you need to make the water level for you to be able to establish whether your tool is actually establishing a horizontal?
Okay, well, let's see. I've used like about a 10-foot sight distance before. I have a longer tube I could use now, but I haven't actually used it yet.
How long's your longest tube?
Like 100 feet, I think. But I haven't used it yet.
Yeah. 100 feet, what's that, about 33 meters?
Yeah.
33.3. Yeah. And that's enough for you to establish a horizontal, is it? Would you go both ways in order to do it? Would you take that water level from the center and go in one direction 33 feet, and would you go 33 meters, sorry, and you go 33 the other way as well? So you do 66.
Right, and yes. Well, in other words, you would check it one way, and then you'd move the water tube level around behind, in other words, and then rotate the thing around 180 degrees, and then make sure that your axis was, is that what you're saying?
Yeah. That's how you would calibrate that total station to horizontal.
Right, yeah.
And would you make sure that 0, 0, 0 was actually at the same point at each side? So establishing that 0 would be the horizontal plane, right? Or is it 90? I don't know. How does it work with that tool of yours?
I'm not sure I understand the question.
Well, it measures angles, doesn't it, that tool that you've got there? It moves up and down because you were clicking through different degrees.
Yes.
Right. Now, when you have the water level established to calibrate it, do you make sure that it reads 0, 0, 0, 0, 0, 0 every time when you're trying to establish the horizontal, in that entire plane? Is that, because that's what I imagine whenever they go and do calibration for an auto level, they're trying to establish that the entire plane is horizontal, i.e. 0 angle change.
So, in other words, for example, if my first 10-foot measurement was west of the instrument, would I then move it or pivot it to the right 90 degrees and then to the right and repeat the instrument to make sure it was reading the same level in all directions around? East, west, north, and south?
The up and down, obviously. The 0. Is it 0 when you're looking straight? When you call it eye level, is that reading a 0?
Very close to it.
Right, okay. Now, when you get your water level to make sure your tool is in calibration, are you making sure that it reads 0 when you're looking at the water level?
Yes, or very close to it. I mean, within the accuracy I'm expecting.
For a horizontal? Would that? That's what I'm asking. Would that not be 0, 0, 0, 0, 0 all the way round through 360 degrees? Always 0. Is that not what a horizontal plane is? And is that what the water level, when you're checking the calibration, is that what you're checking for?
I think if I understand the question correctly, but yeah, I mean that would be level, right? If it's the same height all around, that would be level, right?
Yeah, horizontal plane. Like the guy just said earlier, you're establishing a horizontal plane in order for you to, and that's in every direction.
Right, for horizontal from my vantage point.
Yeah, and with a water level, the water level is how you calibrate that tool to make sure you establish a horizontal plane.
Yes, I guess I think if I understand correctly, I think I answered that, and I'm not sure why you keep re-asking. But anyway,
I'm just trying to make sure, because you say you're not a surveyor and you've never done anything. So what are you doing with a total station at the beach looking over water?
Well, it was, I got it on eBay and I kind of fixed it up, and it was kind of fun.
You got it off eBay. Was it? You fixed it up. What was up with it?
Its battery was no good, so I put new cells in the battery pack.
Okay, so yeah, and then you've used it for what purpose? Did you take it to get it calibrated?
No.
Oh, so when you got it, did it come freight or some parcel delivery?
Oh yeah, it was shipped.
Yeah, and you've never had it calibrated.
Correct.
Okay, and you are looking through the sights of this tool and saying it's interesting that the water level in the distance is higher than your crosshairs.
Yes.
What do you reckon that is because? What have you got any conclusions?
Well, I went back 7 days later, and it was no longer that way. It was back down to below eye level, using the same instrument in the same place on the same beach. But it was kind of a cold, miserable, windy day, and not a warm, calm day like the first one was. And the other interesting clue is that we can see in the picture where the ship was raised up above eye level is it's actually vertically compressed. In other words, if you went up higher on the bluff there, you could see that the ship was actually a lot taller than that. But from down low, you could see that the bottom of the ship was actually raised up more than the top of the ship. So I'm inclined to say that there was almost certainly...
Wait a minute. The bottom of the ship was raised up more than the top of the ship, like upside down.
No, it wasn't above the top of the ship. It's just that the whole ship was above eye level, higher than it should have been on a flat Earth. But the
sorry, wait a minute. Higher. It was above eye level, and that's higher than it should have been on a flat Earth.
It's higher than it should have been on anything except a concave Earth.
Okay, so are you a concave Earther then?
No.
Oh.
Because I went back 7 days later, and now the horizon was back down below eye level.
So does that make you a flat Earther now then? Is that the flat Earth position?
That the horizon is below eye level?
Yeah.
I don't think so.
No, that's what I've been saying all the time. That's the reality position. I've never seen the horizon rise above crosshairs. I've never seen it. It doesn't do. Well, topographic horizons, mountains and stuff like that, they obviously rise above. But the true horizon, i.e. over water, I've never seen that rise above the crosshairs. But there again, I've only ever used an auto level. And my auto level crosshairs don't get adjusted up and down. They just stay horizontal.
Yeah. Have you tried your auto level down 2 feet from the water during black swan conditions.
Sorry, black
Have you
swan
tried?
conditions. What's that?
Oh,
That's a
that's.
falsification condition.
But I mean, there's that picture where you can see the crane, the oil platform, and the horizon goes on forever.
What?
You haven't seen that?
The horizon goes on. No, the horizon is just the apparent junction of the sky and ground.
Okay.
It goes on forever. I mean, I don't know.
Okay, can we back up a little?
Can I'm still wondering what black swan conditions are. The black swan is a falsification thing within logic, right? Is that what we're talking about?
Okay, scratch that. I didn't mean to use that. Let me get the picture.
You are talking about rig oils, yes?
Yeah, the oil rigs.
Oil rigs,
Oil
yes.
rigs. An oil rig is a black swan now, is it? Or you'll have to explain. Sorry.
Yeah, please forgive me for using the term black swan. That's what a ton of people call it. I thought you knew what it meant, but that's not what I meant. And this picture is what I mean.
Okay.
It's a picture showing some oil platforms with obvious just optical distortion going on, and one of them is too far to see because the photographer says he was 1 foot above the water.
Wait a minute. Which one's too far to see?
The
Those
one,
two.
yeah, the one at 9.41 miles.
That you can see it, right? So who says that it's too far to see? Who's making that claim? Because it's obviously there. You can see it. So
bunch of people told me.
What, people told you that you shouldn't be able to see that thing that you can actually see?
Yeah, they said if the Earth was curved, then you wouldn't be able to see that far, and they said the horizon would be a distinct line and not just fading off into the distance.
Who said this? What? I'm unsure as who's making the claim is.
Okay, so basically, my video was in response to something someone said to me. Now you're responding to my response to them, and you don't know what they said to me, so we're kind of getting off in the weeds here.
Well, let's have what the person said to you that caused you to go and get a total station and put it look over water with a total station. What was it that somebody said to you that caused you to do that?
Well, I mean, 3 years ago, a friend of mine told me the Earth was flat and asked me to check into it, and so I've been checking into it.
Yeah, it's not. Did you tell him it's obviously not flat?
Yeah. And when I showed him my angle measurements to some mountains, then he quit talking to me about it. But
what, you showed him an angle measurement to a mountain to prove it's not flat? Because I did a similar thing, right? Like there's a mountain, so it's not flat. Did he act like Lemon did a bit earlier?
Pretty much, yeah.
Yeah, they do. They do. But, I mean, forget about that. Sorry, go on, Paper.
Why just not use term water level and not flat Earth?
Use what term?
Why not to use water level instead of flat Earth?
Water level?
Yes, water level instead of talking about flat Earth.
He's got a paralogism. He's already said that the water level is the tool he would use to establish a horizontal plane.
A local horizontal plane.
But just a horizontal plane, right?
From the perspective of a person at that location, yes.
That's what horizontal is, right? The entire plane would be horizontal.
Oh, can we move on to that? But can I go back to one little thing real quick?
Whoa. But yeah, you yeah, go on.
So we were talking about, I said the bottom of the ship was raised up more than the top, and he says, what was it upside down? And I said, no, it wasn't upside down. And I said, let me get a picture. It's the second from the last picture in the live chat. And this is a different ship, but the same day. But this ship was photographed from down low by the water and then 50 feet up. And you can see how much taller the ship is when you're up high, but you can still see the bottom of the ship in the lower picture. So that's what I mean by compressed. It was vertically squished when viewed from down low by the water. That's what I meant by the bottom was raised up more than the top.
Did you say vertically squished?
That's what I said.
You know who else uses that term?
I look at the picture. I'm just telling you what I see.
Lemon uses that term.
Ooh.
Lemon uses a lot of terms that a lot of people use, but that doesn't mean anything. We all use a lot of terms that a lot of people use.
No, I'm not saying. I'm just saying that the only person I heard say that is that's lemons, like squishy.
All right, so you were asking Bev about horizontal. So for example, if you're in one spot and you use your water tube level and you set up a horizontal plane, and then you were able to, anyway, so you set up a horizontal plane. Let's say you have one of those little rotary laser things that shoots out a spinning laser disc, right?
Yeah, horizontal plane.
Okay, yep. And then you go 8 miles away.
No, that's too far.
It's what?
That's too far.
Why is it too far?
8 miles.
Well, let's say you're up on a mountain peak.
But not with a rotary laser level. That's the wrong tool.
Well, okay, what can we use to represent this horizontal plane? If it's not how about a sheet of glass, a giant sheet of flat level glass?
Yeah, just say a horizontal plane.
Okay, so let's say we establish a horizontal plane, and then we go 8 miles away and establish another one. They will not be parallel to each other.
Yes, they will. They're horizontals. What makes you say that horizontals wouldn't be parallel? Because they're all parallel to the plane of the horizon, aren't they? Logically, that you can then say that all horizontal planes are parallel to each other. I mean, you can definitely say that. That's a perfectly valid logical statement to be able to say. Because all horizontals are parallel to the plane of the horizon, aren't they?
Well, maybe I'm misunderstanding. Let's say you had a 6,000 foot high mountain peak and 8 miles away you had another
6,000, right? And now those are 6,000 feet elevation mountains.
Both of them.
Yeah.
Both
reference to the same mean sea level.
Yes.
Okay.
Exactly.
So they're both vertical height of 6,000 feet.
Correct. And they're 8 miles apart.
Okay. How did you establish the 8 miles? Is that a horizontal distance?
That is the horizontal distance,
okay.
Or you can call it whatever. It's the distance. It's the line of sight distance.
Yeah.
So,
okay.
Would you expect to look straight across at the other mountain or slightly down?
8 miles. Well,
yes.
If we were to draw it geometrically, we would have an 8 mile horizontal, and at each end of that horizontal, we would have a 6,000 foot vertical. Right?
The difficulty I'm having is if you actually go to this 6,000 foot mountain and set up your horizontal, your water tube level, your whatever leveling device you want, and sight out across.
You wouldn't use a water level up on a mountain. A water level isn't a sighting level. It's not an optical tool. What
would you like? What optical tool would you like to use for this?
I don't know. You're doing. Are you trying to establish a level at the top of a mountain?
What I'm saying is that the
Wait,
level.
no. Are you at the moment trying to establish a level at the top of a mountain?
No, I think we agree that you can establish a level at the top of one mountain.
Yeah.
But the difficulty is, if you extend that level straight out, flat and level, to the other mountain, and then go over to the other mountain, it won't measure level there.
It won't measure level. Like, from where? You use the level as the tool to establish the level, right? That level is the tool that establishes level. What are you talking about? Measure, it won't measure.
Okay, let me put it this way. If you had a perfectly straight ruler that was 8 miles long, and you take and set it down from the one mountaintop to the other mountaintop, just a straight, super rigid, perfect, ideal ruler, and you set it across the two mountain peaks, and they're both the same 6,000 feet. If you took your bubble level and set it on the end of the ruler on one mountain, it would say that the other mountain was downhill from you.
No, it wouldn't.
And if you went,
it wouldn't.
Well,
it would be a horizontal, right? Surely.
So you're saying that if a bubble level would indicate level at both ends of that ruler?
Yeah, that's what a level is. Yeah. Do you think it would change? The bubble would move.
Can I ask a question? Since you said it would, as in theoretically. So who's told you that it would show you that the other mountain is downhill from you when they're both at 6,000 feet? Who's told you that?
Well, first of all, it's in all the surveying handbooks. And second of all,
whoa. You're not a surveyor. How many, because you just said all, how many surveying textbooks, manuals have you read in your time of not being a surveyor?
None.
So you're claiming all, but you've actually read none. So where did you get that information to state all, having read none? Who gave you that information?
I have friends who are surveyors, and I have seen like screenshots out of books from surveying manuals that they've shown to people. But I also did my own observation
of a horizontal sloping.
Well, so what I
sloping
did
horizontals. Is that what you're claiming?
Well, let me post another infographic here, if I may.
Can we get the claim first? That you seem to be saying earlier when we said 6,000 foot mountains and a horizontal 8 mile difference, and then you put a massive 8 mile ruler across the top of the mountains, so you would have effectively made what I would call a rectangle, right? Two parallel 6,000 feet verticals and a horizontal across the bottom, and then you put a horizontal across the top. Would you not think that was... Where would you put the slope?
Because the direction of down is not parallel between those two places. What?
Isn't vertical the direction of down?
Question? Where would you put the slope was the question. Can we focus on that, please? Because that's a rectangle you've described, as Bevis just said. So can we focus on the actual question for a moment, please?
Well, don't we have to assume an earth shape to say that it's a rectangle?
No. We said horizontal and vertical. You said, sorry, horizontal and vertical. So that implies a rectangle.
Well, maybe. Why don't we look at the observation I did, and maybe you can just tell me where I went all wrong. Does that work?
Yeah, you looked over way too far of a distance with a tool not designed to do that. That's your error. But we were talking about a rectangle that you described, and you're trying to put a slope on it. Can we focus on that?
I didn't.
Which
I didn't
slope would
describe
you
it.
put on that? Which horizontal would you put a slope on the horizontal that you had as the baseline, or would you put a slope on the horizontal that you've got at the top of the mountain, the ruler? Which of the two ones that we would call horizontal? Which of those two, or maybe even both? Which of those have a slope to it in the downward direction, which is vertical?
Well, a slope is just something that's not perpendicular to down, right? So if the line can be straight if the direction of down is not parallel at various points along the line. So there could be the appearance of a slope one way at one end of the ruler, no slope in the middle, and then slope in the opposite direction at the other end.
No, you can't have differing slopes along a straight line. Really? Come on, Jesse.
Well, look at the picture. I went to one mountain peak, I shot the angle to another mountain peak, and then I went back to the other mountain peak that I shot to and shot back to the first one. It's called a reciprocal zenith measurement. There's a little lookout house on the top of each one, and there was 0.093 degrees of difference. How can I get that much difference if horizontal is level?
I'm sorry, did I not just tell you that you're using the tool over way too far of a distance compared to what the tool is actually designed to do?
Can you back that up? I got the manual and it didn't say it.
Is that the tool we've just been talking about?
Yeah, that's
the total station, the one that you haven't had calibrated, even though you got it as a fixer-upper off the eBay.
You also have established that the crosshair can be either above or below something with that tool.
What's that?
Well, did anyone else hear that? Can you relay it?
Yeah, you're saying that we've established already that that tool that you've got there actually can have an adjustable crosshair, right? You can move it up and down.
Oh yeah, it's for measuring angles.
Okay,
it goes
so
all the way
therefore
around.
We do not know whether that tool can set an azimuthal plane, do we?
Well, I mean, it's designed to.
Yeah, but have you had it calibrated to make sure it can?
No, but I mean, I can do calibration, and if your
you
only
can do a calibration for horizontal.
If your only argument is against my observation is the calibration, that can be solved, and then where would we move on to?
Well, then we would be absolutely certain that you understand what a horizontal plane is, and whether you still think that that can slope. And you seem to be saying that it can slope differently depending on where you are. It seems like you said earlier that it slopes downwards at both ends with zero slope in the center. That's a horizontal line with 3 different slopes to it.
So are you saying then that if my instrument was accurate, I would have read the same angle going both ways?
I'm saying a horizontal has zero slope.
But how do I apply that
mathematically and geometrically, and in reality, right? There's only the model afflicted that believe it can slope and believe it can slope in 3 different directions along the same horizontal. I mean, you've got to admit that's a little bit ridiculous to find yourself in a position where you're saying that and then having to justify it.
So how do I correlate that with observable reality here? How would I I mean,
you tell me, how do you justify it? Sounds ridiculous to me. I
Well,
don't
I mean,
have a
because
model, so
because I know that if I take a 1-inch block and put it on the table, and I take a 2-inch block and I put that on the table, and I put a ruler on it, that ruler has the same slope. If I go to one end and measure the slope and it's 1 degree up, and I go to the other end and measure the slope, it will be 1 degree down, right? It's the same slope, right?
yeah, it's a slope, yeah.
But will it be the same slope at both ends of the ruler on a 1 and a 2-inch block?
The road up is the same as the road down.
Okay, then how did I get such different slopes measuring from 2 different points or 2 different ends of the same path? I should have gotten the same slope going back
What
down.
distance?
Sounds like a paradox to me.
What distance was your table, blocks on your table, and what distance were you from mountaintop to mountaintop again?
Rakia, it's good to see you again. How are you doing, buddy?
Yeah, I'm doing great. Got some simple questions for you. What distance were the blocks on your table apart?
Let's say 12 inches.
What distance were you from mountaintop to mountaintop?
8.04 miles.
Were you in a climate controlled environment when you were doing your block thing, and like inside of a house or AC or
the block thing?
Yeah, you know where your table is. Or was that just theoretical?
Well, I mean, it's theoretical, but I got a ruler here and I got a
Right, but you're inside of a room, right? Atmosphere, like control.
Can I just get a grip of the conversation, right? Because I feel we might be going out, and Ryan's just come in, and he says, I keep popping into this stream to see what's up, and I've never actually managed to comprehend what the aim of these discussions is. Well, the aim of these discussions is to logically work people through the principles and the things that they say. What it seems to me that Jesse's saying is he goes to one mountain and he looks at the other mountain and it slopes down. But then he goes to the other mountain that had just been sloping down. And he looks back at the other mountain and that's sloping down. Is that right, Jesse? You've got a downward slope from each end.
If they were the same height, yes. In the experiment I did, they weren't exactly the height. So what was a slope, one was looking down to the other and the other was looking up to the first, but the difference between it was not the same slope. But if they were two identical heights, then both would be looking slightly down at the other.
So there would be a slope downwards at both ends. Now, can we, because we've done this before, equate this to a canal? Let's say 8 miles long, right? Let's say it's an 8 mile long canal, maybe 6 miles long or whatever, right? Now, at one end, if you're looking down it, does the water level drop? Is there a slope in that direction that you're looking of the water level?
A non-moving canal, I presume?
Yeah, a canal. Yeah, static.
So, well, could you repeat the question?
6 mile canal, stretch of canal, right? And you set up your tool, like you said, and you're looking. Does the other end of the water level, is that lower, and is there a slope in that direction that you're looking from one end of a 6 mile canal?
Is there a slope to the apparent horizon on the canal, or does the water itself slope?
Just imagine there's a little mountain peak at one end of the canal, and then 6 miles away at the other end of the canal, imagine there's a little mountain peak over there. Now, they're both at the same elevation, right? So they're, i.e., the same height. Would you see a drop, a slope of one end of the canal, the mountain peak, from the other end of the canal, the mountain peak? Would there be a slope in that direction, like you've just explained.
Oh, so if we have, are you saying if we have, say, 2,000-foot mountain, 2,000-foot
No, we're
towers,
talking
whatever,
a 6-mile stretch of canal.
Okay, 6 miles of canal, and then equal height mountains on each end, so that we know how
Well,
high
we
the
can just
mountain is.
imagine that each end of the canal is an equal elevation mountain.
Okay.
Now,
So
is
the
there a
canal is-
slope in your? If you take your tool to one end, would there be a slope downwards in the distance?
To the top of the other mountain?
Yeah.
Yes.
Okay, now if you go to the other end of the canal and look back, is there a slope downwards again?
From the top of the other mountain now? And,
Yep.
And shooting back? Yes.
Okay, there you go, Ryan. That's what we're trying to do. Just go over the logicness of Jesse here, imagining a downward slope in both directions of the same horizontal straight line, like one straight line having two opposing slopes. That's right, isn't it, Jesse? Reciprocal.
Yeah, it's called a reciprocal zenith reading, and it's one of the things that surveyors learn in surveying school.
So, like, have you heard of Rumpus?
Yep.
Have you heard of the Bedford Level Canal?
Yep.
Yep. It's about 6 miles.
But they weren't up on 6,000-foot high mountains.
Because they don't need.
No, the water. We're talking about the water level, right?
Yeah, the canal would be representing your 8-mile long, super rigid, super straight ruler that you detailed earlier. It would be the water level in this scenario. That's the equation.
And you have a double slope. Or we call that the double nutsack. The double drop. Because what you do then is, that sounds ridiculous, right? Having the water sloping away. Like a static body of water sloping. I mean, that does sound ridiculous, doesn't it? Even logically, most people try and backpedal and take it. So, I mean, do you want to try humping it? Because they both have to be at the same elevation, don't they? And with no slope, because that would make water flow, wouldn't it?
Mm-hmm.
Well, how then do we explain my observation?
It's just an observation, right? Surely it can't override logic that tells you how water flows, right?
Well, logic is only as good as the data that it is working with.
Yeah. It's only as sharp as the mind that's using it, right?
And in my case, that's not much. But
well, you're the one that says you're justifying a slope in both directions. Does that sound logical?
I'm not justifying it. I'm saying I've measured the angle difference.
Yeah, does it sound logical, though, to you?
Well, it's an observation. It's data. What does it matter if it's logical or not? It's what I see. It's reality.
Mm-hmm.
So we're supposed
You've got to
see
apply reasoning to something at some point, though, right?
Oh, definitely. And that's why I'm asking for reasoning as to what could possibly cause this non-parallel slope situation.
You've been told already.
Definitely not a slope, right?
Earlier, you told us that you observed with your total station over water, and then went back 7 days later and you saw something very different.
Yes.
So over distance, optically, things seems to change, right? So why would that not be taken into account in your 8 point whatever mile distance observation?
So what I found is that when
No,
the
no,
line of
no,
s-
no, 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 no. I had a direct, specific question. Why wouldn't the optics that you described so nicely earlier be taken into account on your mountaintop to mountaintop observation?
because it's the line of sight was not close to the water.
Okay, so
Filter
water
medium.
causes the optical effect. Is that your claim now?
The line of sight being close to the water has clear observable effects on the line of sight. Otherwise, that ship would not have appeared above eye level.
It has more effects, but the line of sight through any medium, especially when distances increase, you would expect as a logical person to understand that those observations are going to be different than one that's up close, correct? In a controlled environment. That was my point earlier.
Mm-hmm.
Surely you can logic that out.
Well,
as in obviously you wouldn't be on top of each mountaintop at the very same time under the very same conditions. You would have to physically move from one top to the other.
And don't forget the fact that you don't go up to the top of a mountain to establish level.
Exactly.
I mean, that's ridiculous. Nobody ever does that, Jesse. And you say you've got surveyor friends. Surely they should have told you you don't establish level. You just do trig points, right? You establish an azimuthal, and then you take the angular measurement on the horizontal plane.
do you know any surveyors you could hook me up with?
Do you not know any? You said you've got friends. And
Well, I do.
have they
You obviously-
never told you that you do not survey over water, particularly with any sort of distance, right? Especially over the recommended distance over water. You just don't do it.
No,
Surely they must have told you that.
My surveyor friends doesn't say I'm doing anything wrong, so that's why I'm wondering if you have one you trust that you can introduce me to.
What about Todd? That video we just went over,
the
who showed us
Illinois
how
surveyor.
to do.
Yeah.
Yeah,
Can you-
that guy.
Could we ask him?
Yeah, you could. I mean, I would say to any of your surveying friends, ask them how accurate they normally are whenever they take sloped horizontal distances over water. I mean, what exactly was it you were doing? What was the purpose of you taking that total station and placing it and looking over water? What was the purpose of the sighting?
Oh, where the ship looked up above eye level?
Is that what you were doing, to go and find a ship above eye level?
No, I just asked. No, I didn't know it was going to be. I just wanted to know what the angle would be. I thought
So
this is a nice day to go out and see what the angle will be. So
The
I went
angle that you could get the horizon above. Was that the intended purpose?
I beg your pardon?
Because you got the horizon above. Is that the angle that you were looking for?
I wasn't looking for any angle. I was just measuring the angle that was there to be measured. I'm not sure I understand the question.
What did you go to the side of the water with your total station for? What was the purpose of the visit?
To learn, to observe.
Okay, but when you brought up this oil rigs picture, you said that someone said to you that we can see too far. What did you mean by that?
Hey, gentlemen, I'm really enjoying this discussion, but I need to take a break and get some stuff to eat and everything. I would be delighted to come back and discuss it some more. Would that be okay?
Yeah, fine. Fine.
Alrighty.
Just check up with Rumpus while you're out gone for a bit. I mean, he says you're doing
Okay.
a bad job. So you
Yeah.
best make sure what the council's saying.
All right. Well, thank you so much.
No problem.
It was a pleasure.
So, what's everybody think? Anybody else ever wondered what angle measurements they could take at the side of the water? Anyone? Let's
I
go
would
and...
say that that was the bias because it was in that question if we can see too far on this oil rig station the picture. So I spotted that this guy Jesse had a bias because on the globe we shouldn't see so far. So if he said that we can see too far, it means that considering globe, of course.
No, it's just
So
considering something. They're considering a model that makes them able to say we can see too far. I mean, it's a ridiculous statement for anyone to ever say.
it is ridiculous, but it says what the case is, because normally you can see as you can see. So why someone should be worried about if he can see too far or not too far? Just we can see what we can see. But if there is too much to see, it means that it doesn't fit some model.
Yep. It's a ridiculous argument, that. But I mean, I'm more interested in the slope for Jesse to help Rumpus. I mean, I don't know whether Rumpus is actually going to go for the reciprocal nutsack drop. I hope he is, because it'd only be fair.
Let's be honest, when he goes from peak to peak, just the angle of the sunlight, the source light, would change the position of the distant object. I mean, look at the top right corner of his pictures, how blurry it is and distorted. Go back on different days, and that's going to look different. You're going to get a different angle on different days. I mean, he answers his own question. He knows it's distance. He knows it's atmospheric conditions that are causing these things. It's just the way it is. It's not getting a true measurement over 8 miles.
I'm mostly interested in the fact that he would, say about the horizontal base level that the height of these mountains, these theoretical mountains, are measured from. Their height is measured from the same
horizontal
mean sea level. Yeah,
Yeah.
the same horizontal plane.
He even had the
And
water level to calibrate his total station.
Yeah, the horizontal
to
plane.
horizontal. Yeah.
Mm-hmm. And then how we can create this rectangle, but have the top of the rectangle, the long line on top between the mountains sloping in both directions at once.
Trapezium.
It's intense. Let's just say.
Yeah, there's some weird wizard tricks that have been played, right? Wrapped
Yeah,
up in a
somebody must have said
paralogism.
something.
It's a wizard trick.
And why mountains when you can do that on the canal or water?
Yeah.
Which is much easier. And you don't need to climb so high.
It's harder to obfuscate, though, right? It's
Yes,
harder
because
to perform the mental trick of a slope when you're talking about a canal.
Yeah, because people do know that if you put water on the slope, it flows down the slope.
Yeah.
So, yeah.
Much easier to visualize a mountain. Yeah, it's crazy. Crazy what people imagine things.
I guess that's the best part, is he would readily say that this was all theoretical and imagined and all of that.
Oh, thanks for coming in, Jesse. Because you have to remember, he keeps talking about a slope down, yet had a video of saying that it's above, which contradicts everything that he says about a slope down. Once again, proving that something optical seems to contradict something that he himself is saying. And he can't seem to see that it might be the optical effect that's causing all of this in the first place.
Yeah, that was my point. He already explained he went back 7 days later for that one, and it was different. It was below the second time. So he knows the optical effects are at play here, and like Rakia said, would be different. Even the angle of the sunlight would be different. Like the conditions would be different. Can't take the same measurement from both mountaintops at the
He's
very
not
same
taking a
time.
measurement though, right? He's just
Oh, right.
taking
Yeah, my bad.
an angle, right?
Mhm.
Yeah,
That's
he's
it. The
just
only
viewing
measurement
through
is
an
an
optic.
angle.
Right. To a
Observation.
point that's so you can't even tell where you're. You're just pointing at something in the distance. You're not measuring anything, and you're
Yeah.
only taking an angle. Good luck.
Yeah.
Hey, write it down in a book. Draw some cartoons about it.
Yeah,
I think
cool.
I think it's clear, at least for the people in this conversation listening, that he knows about Rumpus and he's heard about the different people, and so he's gone around the circuit and been told some stuff about being able to see too far and like these things that he's heard. He's just relaying back now. So I wonder who's been telling him this stuff. Then he's obviously bought it, hook, line, and sinker, and it's just relaying that information back to us now.
Yeah, well, I keep saying all along, there are no globe surveyors. Anyone that was around to have questions asked of them, they've disappeared. They've done a runner. So there's nobody to ask. And everybody else seems to have zero surveying credentials. They might have the tools. I mean, can you imagine somebody going around with a total station that you've got a fixer-upper off eBay and you're going to the side of water and looking over water with it? I mean, no surveyor would do that. No real surveyor.
I would make the claim that only someone who is in this arena would do that.
Yeah, this is the only reason somebody would actually do something like that, is because they're model afflicted and they need to try and prove a point to someone about something, right? Somebody's decided that they need somebody to get some pictures of something that sort of could possibly, somebody could think, I mean, watch that video with Jesse Gordon. You could believe it's a surveyor. He's a surveyor. I mean, why not? He's got a surveying tool. There are other pictures of other quotes surveyors that do similar sort of things, take pictures over water. I can name two of them that do that. Jesse Kozlowski and the guy from Maine. Both of them have looked over water at lighthouses, miles in the distance, something that no surveyor would do. Especially try and equate elevations to it. You mean you might be able to triangulate on the azimuthal plane like we explained earlier, but you definitely wouldn't be doing elevation. Trying to establish elevations over distances with a tool that isn't really meant for leveling. It's meant for measuring angles, like he said. Any wonder?
And his specific tool is not calibrated, which he readily admits to as well. Which, yeah, if he gets it calibrated and goes back and tries this over multiple times, his mountaintop to mountaintop thing, he'll get different results every time it does it, like Rukia pointed out. So it's not going to be a measurement. It's going to be an observation only.
Got Rumpus in the chat making the same claims as what Jesse just did. Says all the professional literature contradicts Bev and agrees with me and surveyors. That's what Rumpus says. Rumpus is on the side of the surveyors, and they all contradict me. And then all I'm saying is that level is quite obviously horizontal, provably. And everybody disagrees with me, apparently.
I've heard 2 surveyors talk about level and horizontal, and both of them has said that level is horizontal.
Yeah, the
2
Illinois
actual
surveyor
real
was
surveyors.
saying it. He said it multiple times.
Yeah, he's one of the ones I've heard. And then that video you have where you talk to that surveyor at the side of the road, he says it too.
Yeah.
Yeah, those are 2 real surveyors, actual working surveyors. I mean, Rakia has however many surveyors working for him, right? So Rakia, they will tell you every day, all the time. Level is horizontal.
Yeah, there's no need to harass surveyors, but I mean, if you ask a surveyor, he'll tell you the truth. He'll tell you, yeah. And just saying that won't make them flat earthers. They'll just be telling you about their job and what they do and the tools, how they're calibrated. It's ridiculous to think that there is people like Jesse and Rumpus in the chat proclaiming to know more about surveying than, I don't know. I think they're going against what the Illinois surveyor said earlier. And he's a representative of a professional company. So I don't understand what Rumpus and people like that are trying to do. I don't think Jesse actually, realised the implications of what he was doing, because he was using a tool that definitely hadn't been calibrated to try and give an impression of something that seems impossible. The water level being above eye level. I mean, it's ridiculous. I don't even know why you'd put that out, because it seems to make you look like a concave earth, or even he said that.
It shows you that optical, effects will have, vast impact on your observation depending on the, conditions of that are there on the day of your observation. It will change drastically from day to day. That's what it shows.
Yeah, Rumpus is going to show the slope of the water level.
Yeah.
Only one way though, right, Rumpus? You're not doing reciprocal slopes of the water level. Just a one-way slope.
Will it be a multiple day observation, Rumpus, or I would imagine, right? Or at least multiple times of the day?
There should be a time lapse done, right? Over
Of
however
course,
many
yeah.
hours.
Yeah.
Like that one that looks like the whole Bay Area is moving around all the time. Yeah, do one of those time lapses.
Just do reciprocal. Get it over and done with. Just get the double nutsack. Get it done. Because you're always going to be asking you a question, aren't you? One-way nutsack. Wonder what would have happened if we'd have gone the double. $17 foot, I think he's looking for. 17-foot slope.
That's ambitious. Instead of going for the hump, he went for the slope.
Oh yeah, Mobius has got a good one there. It's a bit one of those paradoxic ones, right? But take this one, Rumpus. He says, is Rumpus planning to use a horizontal line to show sloping level? Or is he using a level line to show a sloping horizontal?
Nice one.
Which one? Which one's which? I'm guessing, seeing as mathematics says a horizontal has 0 slope, you can't really go against mathematics and start sloping horizontals. That'd be a tough one. But I mean, who knows? Who knows what the model afflicted can go to? What places they can go to? I'd say he's looking for the slope of the water level.
He says he'll be doing observations period of 8 hours or so. Okay, good stuff, Rumpus.
Oh,
So multiple times.
Rumpus, he's got about 15 people coming and he can't do it over multiple days. So it's just a one day event. 8 hours. Nice. Set up in 8 hours. That's good. You are using the water level, right? Yay! Boom, now we're getting some stuff. Rumpus, are you doing your video soon? You said it was in production, the video explaining what your test's going to do. He says, I will be using an auto level to create a horizontal plane and measuring the level surface of the water with respect to that.
I can feel the excitement in the air already.
Here we go. There we go. There you go. Look at that. Well done, Rumpus. Thank you very much. So he is measuring the level surface with respect to the horizontal plane. And the slope is obviously the distance away from the horizontal plane that the water goes. So it does look like the slope is on the water level. So there you go, Mobius. Does that answer your question? The slope, measuring the level surface of with respect to the horizontal. So it must be a slope of the water level. A level to establish a horizontal. Yeah. And you can check the level with the level to disprove the level is the tool for establishing a horizontal. Is that about right? Rumpus is using a level to establish a horizontal plane that he then hopes to use to prove that the level, the water level, isn't horizontal. Sounds a little bit like a stolen concept fallacy in there. Possibly. You use a level to prove that level isn't horizontal. You use a level that establishes a horizontal to prove a level isn't horizontal. That's definitely a stolen concept fallacy, right? Is that a pretty good explanation of what a stolen concept fallacy would be? Could Rumpus have just come up with the perfect explanation of the stolen concept fallacy?
Yeah, that's a good one.
Well, Rumpus, you better get a move on it. We're in mid-June. You got 3-month window left here.
Wow, Rumpus is a little bit triggered. Rumpus, are you aware of a fallacy called the stolen concept fallacy? And how ridiculous that actual fallacy is when you push it through to completion? Because it seems you might be committing the stolen concept fallacy.
Rumpus is kind of a nice gauge. You know you're on the money, as it's called. The more triggered Rumpus gets, the harder he calls you moron, the more correct you know you are.
Yeah. Yeah, I mean, I'm really hoping that Rumpus is at least going to do a presentation on blues. He can team up with Wally, actually, because Wally's got that one explained. Beddy is the guy to explain the stolen concept fallacy to you, Rumpus. He might help you out. But I'd say that using a level to establish a horizontal plane of reference to then try and prove that a level, a water level, doesn't establish a horizontal plane of reference whilst using a level that does establish a horizontal plane of reference.
Did you say on blues?
Yeah, I think Rumpus is Blue's second man, isn't he? He's like deputy second in charge of Blue Ops. Rumpus,
Ooh,
as far as I know.
Rumpus second? No, I think not.
He was co-host of the Blue Show. Well, I mean,
right.
I mean, last time I was watching Blues, I mean, admittedly, I don't watch too much of them, and it was maybe a couple of months ago. But when Blue was doing, when he was going, when Bob decided to stop doing his live stream and Blue took over, whether Blue nobbled him, but I really thought that Rumpus was Blue's sidekick, second in command, right? He was the guy that Blue handed over to do presentations and stuff. Is that not right?
I don't know. Somehow I don't see Rumpus as second fiddle.
Rumpus, he doesn't.
Yeah, you could be right.
Yeah. Rumpus is saying about the stolen concept fallacy. His measurement. He did say he's got an auto level, right? Rumpus, you did say you're using an auto level and then saying your measurement. I'd like to see that measurement. We could bring our measuring rods. Have you got measuring rods? 15 man strong. You will do a presentation on blues. See, look, I told you, it's doing it.
Okay,
He's got his
cool.
video ready and his presentation and everything.
I thought he was gonna do it on his channel, but yeah, Blue. I guess Blue is okay.
Yeah, Blue's got a bigger crowd than Rumpus's channel. What, Rumpus? Drop us your link to your channel in here. Everybody's been asking. They can't seem to find it. Or have you been banned or something? Are they not allowing you on YouTube and that's why you're going to Blues? Well, that'll be it. He'll have had his channel shut down. He will not be allowed to be on YouTube. Yeah. Oh, you've got an auto level. Nice. What about your measurement? There you go. The Rumpus. No space. Drop it in the thingy chat as well if you can, ask him, please. Oh right, McToons as well. Look, he's doing a show. He's doing a tour. Rumpus and the Bedford level canal slope.
A trifecta. Yeah, yeah.
Tour.
And others, yeah.
This is good, Rumpus. So we can safely say now that since everybody else has been going for the hump, Blue's going for the hump. Oh shit! Have you had a word with him about that? Not too sure. How do you think Blue would go with that? Guess he's gone for the rise in the distance, but then it changed the next day. No measurement to tell us how much difference the water level changed. It could be anything up to a mile or something in the distance. I don't know how high the water got. And but Blue's gone for the 90-foot hump in Lake Pontchartrain, and Rumpus is going for the nutsack drop. It's got to be a conflict there, hasn't there?
No. Doesn't want to take the spotlight away from his buddy, so he's doing another thing. Could it be that?
Oh, but Blue has the unclamped/clamped thing going, so maybe he can try and fit it into that somehow.
I think. Do you think Rumpus will ever back down and meet him halfway at a hump? Just put a bit of a hump in it. Or do you think Blue is actually going to have to back down and put a slope to his? Right, from each end of Lake Pontchartrain. Which way are they going to go with it?
Well, that's true, because if he finds a drop, then he's in direct conflict with his buddy.
Yeah.
Uh-oh. Spaghetti-o.
That was that's the initial, the double drop hump, isn't it?
Yes.
Like they bring us right back full circle to the original contradiction that we all saw.
That's awesome. Turn around and be like, we're going to show you that it's not a contradiction. And then they come up with contradicting.
Come up with a contradiction. Yeah, Blue and Rumpus. Fight. Yeah.
Maybe they can find a way to squeeze them both in. We'll have to wait and see.
No doubt there will be loads. Like Rumpus has said, he's doing presentations on it. So surely, all of the Globers will be sure to point out any contradictions that they see. Because I've heard that they're quite good at pointing out contradictions that they see. Or maybe accepting contradictions. I hope everybody else will be pointing out contradictions that they see.
Oh.
I sure will.
Rumpus has backup if needed.
He's got a 15-man team.
No, but even plus beyond that if needed.
Like the Flat Earthers agreed to help Rumpus if he needs it.
That's right.
This is getting better.
Uh-huh.
Is he one of the 15?
No,
Do you
no,
reckon?
no. No, definitely not.
Well,
That's extra help.
That's where he needs help, isn't it? Rumpus.
No, but I think it's
15
beyond
flags
like
up.
the 15 is, the people that are going to fix the poles and, work the phones. I'm sure he's going to need people for bringing water around and sandwiches, and it's a big undertaking, 15 people.
I suggest nuggets.
Picnic. Oh, come on. You've got to have picnics on the canal.
Think about just shuffling water and food back 6 miles. You're going to need like dingoes or four-wheelers or whatever.
No,
You're not walking
not
6
round
miles
here. No, you just station each person at those little bits and say that that's where their job is. And Rumpus is obviously be looking through his auto level on the bridge, shouting out commands at people. Won't he? Who wouldn't want to do that? Turn up, Rumpus tell you where to stand, and then have him sort of chatting with you, or he thinks he's going to chat to people, but I don't think he's tested out any of the communications.
Rumpus wants to add here on his tour of presentations.
Does he?
Yeah.
Okay. Is that like does he want an early one or an after one? Like, is he after doing a presentation afterwards? Because it's historic. I'd love to see a presentation of how you come to your conclusions.
I think he wants to secure posting rights before he gets posting rights for the day, diagrams and all.
Yeah. Do the test, Rumpus.
You hear that, Rumpus? You're good to go.
Yeah. You want to come and do a presentation of exactly what you did whenever you did it, with pictures and video and explaining all of the geometric procedures and everything. Yeah. Slope of the level, all of that sort of stuff. But be aware that we do understand what reciprocal is now, and I'd like to see a reciprocal slope of that canal.
Yes, he has taken care of catering, apparently.
Nice.
Hey, he's on the ball.
Help from the locals.
He's on the ball. I get it. Boom.
Yeah.
Help from the locals.
Well, there's nothing now to do but to make all those videos he promised, do some live streams, and go do the test. He hasn't done any of it, to my knowledge, yet.
Well, I've been asking for these videos because I would really like to see what Rumpus is aiming to do, like the methods and everything.
Yeah, do you think there would be a possibility of him setting up a modus tollens or ponens for his test to come up with some sort of a conclusion for it?
That would be handy, about the sloping water level.
Yeah.
And just for clarification, he's doing a long distance, low level observation over water, correct?
Yeah. Yeah. Well,
okay, I got it.
He's about. I think we measured about 5 meters above the water level of the canal on the bridge. So 5 meters above the water level. Just didn't really see that far with the auto level, but I think that's what he's using for his optical device, an auto level. Nice. Rumpus is going to do detailed videos soon. But I'm sure he said that a few months ago, didn't he?
I think that was his exact words.
Yeah. And maybe he might have said that a couple of times.
Yeah, the window's closing, Rumpus. Figure at most you have 3-4 months.
He's had large teams of people at the site already. Ask Farmer's Boy, WS, and others to confirm the scale of the operation, and we will see videos soon.
Ah, okay.
Well, we
Been
did
at
see
it.
Rumpus and Farmers and an other. So I wonder whether that an other was WS. But I mean, I wouldn't call those 3 people large teams unless he's got others. I only saw 3. And we only really saw Rumpus from a distance. It's good. Good to see Rumpus. Nice weather. Maybe a little bit too hot, but hey, lovely weather. Good time of year to be going to the canal, Bedford. Historic place. And historic times coming. Rumpus going for the first guy to ever measure the slope, the full nutsack. Going the full quadratic. No, not you looking for the hump like usual, people. Rumpus going for the full nutsack.
That's it. I can feel the excitement in the air.
Yeah. Tension. I can feel it ready. It's going to be nerves for Rumpus. I bet he can hardly wait. It's like be putting his name up in lights, won't he? The Rumpus.
Robotham? How did we say it?
Yeah, Robotham.
Robotham?
Wallace.
Wallace?
Yeah.
Rumpus and the lad. Oh no, the lad first, then the Rumpus.
No. You've got Wallace and Robotham having a battle and a fight, and nobody really knows who wins, and it's all obfuscated. And then Rumpus is coming in, going, "What are you dudes measuring the hump for? You should be going after the full nutsack drop. Just get that slope measured."
Ah,
Boom.
okay.
Look at that.
Pushing both aside.
Yeah.
Like, get out of the way, you two.
Yeah, who are you guys? I mean, I'm going for the slope. You've got to think big, haven't you? Don't go for those little piddly humps. Go for the full nutsack drop, 17-foot slope. Boom, get it down there.
Oh, this is good.
Yeah. I like it. Everybody here, like, he'll have a throne to sit on. Rumpus and the Globe Tour. Sloping water levels for the win. Everybody can do it. He'll set up a sloping water level kit. Prove the globe with a sloping water level.
Will he mention us mere mortals when he becomes famous, I wonder?
Nah.
I once knew these guys that thought level was horizontal, like maybe like that in a passing jet.
But since I measured the slope of the water level, then that puts to bed all of those claims of level being horizontal. The same thing. Can you imagine? People back in the day, thinking that level and horizontal are the same, geometrically as well. They'll have to rewrite all sorts of things.
Who knows? He could be laughing at us in a few months. I mean, you know, we don't know.
Rumpus has got souvenir participation souvenirs for people that came. No joke. He's got laser cut souvenirs.
Oh, you're right. Jeez, he's going beyond the Call of Duty. Holy cow.
George, Rumpus is using an auto level. There's no need. And that what Jesse was using a bit earlier, he called a total station. For measuring angles. Saying I don't understand what a theodolite can do. Theodolite can definitely measure angles. I think that's what the main purpose is of a theodolite. Measuring angles. Yeah, Rumpus knows how to set these tests up, Askin, doesn't he? You get participation souvenirs. And it gets on-site catering. Yeah,
what's George gonna do? I wonder. It's gonna be on-site manager or something.
I don't think George can come with his dog. I don't think he'll be allowed. But George can definitely help.
Like coordination.
Yeah.
I think George has experience in that.
Yeah, George is calling Jesse an idiot.
What?
Yeah. Jesse said he had a total station, but George is saying it's an idiot. A total station is a theodolite with an infrared laser to give a distance measurement capability. So that's what he should have said, Jesse. Well, Jesse just said he had a total station. But George is saying that's you're idiot for saying it's a total station. You should say it's a theodolite with an infrared laser to give it a distance measurement capability. Just to stop you from being an idiot. I think that's what he's saying. Yeah, I don't think George is coming. Rumpus will have to get... I mean, but he's got a team of 15 people. And that's without any of the next level of P1000, P900 cameras going to help out. Not prawn, Mike. We have salmon and cucumber, I think. Triangles. Maybe just quartered. Little tiny ones. Maybe crust removed. So yeah, this is got a little bit sidetracked, haven't we? But good to see Rumpus is coming out after the Illinois surveyor to show us how elevations are measured. Reference to a horizontal plane, a tool called a level that established the horizontal plane, and you measured a vertical distance from that, and you then use those measurements to compute an elevation at the end point, which I'm presuming is the elevation of the other end of the water that Rumpus is going to check. Yeah, George. That's what Jesse said. He had a total station. One that he hadn't had calibrated. He got it off eBay as a fixer-upper, and he fixed it up, but didn't get it calibrated. Checked whether it was in calibration or anything. But he uses it for going to the side of the water and measuring angles to the horizon, I think. I don't know. You want to watch it, George? He's with you with the rising horizon. I know it sounds a little bit concave earther. It does sound a lot concave earther, actually, doesn't it? In fact, it's entirely concave earth. I don't think anybody else would ever say anything like that. It's a
concave enough to hold a pool of flat water on the top. Shallow basin, concave earth, maybe.
What, getting the water level to rise in the distance? To have the water level in the distance above eye level, i.e. higher than you are. It's entirely a concave earth claim. Isn't it?
If the horizon rises past eye level, yeah. It'd
Yeah,
have to
that's what-
slope upward at 8 inches per mile squared or something like that.
That's what Jesse and George have claimed. A horizon higher than eye level. So, again, make of that what you will. We've just explained that it is obviously an entirely concave earth claim. Yet George and Jesse have said that. Shown pictures of it, in fact. George says you don't need to take a theodolite or a total station to get it calibrated. I guess George is just saying that because George runs a professional calibration thing and, he does it all himself anyway. But Jesse said he didn't do any calibration, George. None. He hadn't got it calibrated. So that's the particular one we're talking about. But if you're saying he doesn't need to get it calibrated, he got a fixer-upper total station off eBay, fixed it up, and you say that he doesn't need to get it calibrated. Well, I guess if George is going to say that, then, I mean, why would Jesse ever need to get it calibrated? George has got a calibration corridor in his workshop by the lake. He told us about it. It's where he does all of the calibration for the local surveyors and stuff. They bring their tools to him so he can calibrate them. I think he said he had a professional calibration business. That's what he does. Calibrate stuff.
George does?
Yeah, I'm pretty sure I've got a video with George saying he's a professional calibrator. Something like that. He has a calibration business. Definitely has a calibration hallway. Because I can remember that. I was trying to get Buster to write a song about it. It does sound good. Calibration hallway. Calibration corridor. So, on Hump Day, it appears that we have given up the hump and Blue's hump from Lake Pontchartrain. And Rumpus has overtook it with the slope. Yep, slope. So, Blue, game on. How to measure the slope of Lake Pontchartrain. Should be easier. It's like 4 times the hump, isn't it?
But if he finds a slope, how are they going to reconcile that with the hump? I don't see it, how this is going to work out.
Well, it should be easier. Like Rumpus is going for the drop, the nutsack drop. So if Blue goes for the nutsack drop, you can take that 90 feet. Is it 90 feet? Yeah, 20 odd meters, right? And you can times it by 4. You can quadratic. You can look for, what's that? 360 foot. A drop, slope, 360 foot. Should be much easier to get that, shouldn't it?
Wow.
There you go, look. George says yes, big letters, big, like a shouty yes. Yes, I calibrate all sorts of electronic equipment, spectrum analyzers, network analyzers, multimeters, surveying equipment, etc.
Wow. I thought he was just into the electronic stuff and the surveying. Okay, wow.
Yeah, so he would definitely know that whenever you set up a level surveying equipment, you have to calibrate it to horizontal, as in an azimuthal. It's got to be on the horizontal plane. George knows that. He calibrates it. George claims he shouts it. Yes, he is a calibrator and he does calibrate surveying equipment. That surveying equipment establishes a horizontal plane. So George will tell you if he calibrates surveying equipment. Level is horizontal. George can confirm it.
So he must have the ability to put that sticker on when you get it calibrated, like the official thing there?
Calibration certificate. He must be able to issue calibration certificates if he calibrates all sorts of electronic equipment. Yeah, but see, you didn't know. You learn new things all the time. George actually calibrates surveying equipment. And here we have been saying that level is horizontal, and George has been saying it's not. So, I mean, is that not a paradox? George, do you calibrate surveying equipment to horizontal? So you do calibrate it to horizontal. George, it's hard work to understand what he's going on about here. I perhaps should find some way to get the text chat. Anyway, you have to be watching the YouTube chat. But I don't know. George might be having a bit of a breakdown. They are either, George, if you calibrate tools, do you calibrate them to horizontal? And if not, what are you calibrating surveying tools to? It can't be calibrating them to 360 degrees. Rumpus, no, Rumpus, you don't calibrate it to horizontal. Please, Rumpus. Make sure you've gone to an actual place to get your auto level calibrated. I would. You're having a debate. SE's gone. Rumpus says to SE, when we have our debate on my channel, I will explain to you how you can have a hump and drop. So Rumpus is going to have a debate with SE, and in that debate he is going to have an explanation of how a contradiction can occur in Rumpus's mind. You know, when I said earlier that we haven't put out the 2-peg test, that's for a reason, and the reason's just been shown. George says that auto levels calibrate with a 2-peg test, but not theodolites. George actually thinks that you calibrate an auto level with a 2-peg test. See you later, George. He's out. I suppose when you say some stupid stuff, then you have to leave. He'll be back, asking. Don't worry about it. He'll be all right. He'd go and check over there with Blue. Make sure he's all right. He did just say that you calibrate an auto level with a 2-peg test, which is a little bit ridiculous. Beginning to worry about Blue and George. I don't know. I hope Rumpus is keeping an eye on George as well. Right, see you later, Rumpus. Off you go. Thanks for popping in. Thanks for letting us know about your test. Let us know when your videos are out, ready for you to explain about what your test is. It's historic. You should be doing well there, Rumpus. So that's good. We've come back for the on Hump Day, and Rumpus has shown up to talk about his well, in the YouTube chat, to talk about his Bedford level, the drop of the water level in the distance, the slope. I like it. And he said he is going to explain to SE how you can have both a drop, like he's going to have, of slope, and a hump, which should put a rise in the center, like Jesse showed, where the water goes above the crosshairs. I don't know whether he can get his auto level low enough. It has been good today. Has been really good, actually. So everybody need to talk to Rumpus or go and do the debates or anything. We will just wait for Rumpus's detailed video explaining exactly what he's going to do with his test, how all the measurements will be taken. 15 people sounds like a very large operation. When me and Spot On did our water level test, our straight line test, realizing Euclid, there was just him and me and my two lads, just the four of us. So 15 people seems like quite a lot. It's a big job. And it is quite a long way walking down that canal. It's even a long way driving from one end to the other. You've got to go all the way around. This test feels like time travel. How long ago was this test spoke of? Rumpus's test? Wow. I don't know how long Rumpus's test has been going. I don't know how long Rumpus's test's been going. I'd never heard of anybody that going for the full nutsack drop. When I first came into this, I'll get a picture, which I asked everybody. I went over to Gems. Oh, might take me a while to find it. Oh no, there you go. This one. That picture. The ball-in ballers. There's ball-in baller A and ball-in baller B. And they're both standing on next to their model. And A is the one where the level at each end has the same elevation with zero slope, and B is the drop. So there's a hump A and drop B. And when I was asking all of the guys, there isn't many people that go with the it's like a peeing contest. Yeah. Well, there isn't many people that go with the water level as being B. If you have the globe model, the paradox comes with the hump and the drop. The drop of the water level just seems ridiculous because everybody knows how water flows. And Buster's sung about it. we know how water flows. And that goes downhill. Down. Which is B, obviously, the slope. But that's what Rumpus is trying to measure in Bedford. B. In that drawing is what Rumpus is going for. So Rumpus imagines drop. Rumpus imagines he can measure that drop of the water level in the canal. That's good. Balling ballers are always crying. I mean, you'd be crying too if you had to try and justify one of those models of water level. Which one would you choose for the water level? There you go. Hump, drop, or just horizontal? That's why they're always bawling, crying. They leave themselves in the state of paradox.
Balling because they're balling. Oh, that's funny.
And the tears just cause the water to show level, which makes them cry even more. I think that's how a legend says how canals were made. Globe of tears. Because even globe of tears are horizontal.
That's a lot of tears.
Yeah. Yeah, well, I mean, they've been crying for years, haven't they? I mean, you would be if you had to justify a drop or a hump. Can you imagine?
Yeah.
Blue says hump and Rumpus says no, drop.
Yeah, I guess they say the only thing that can block what's beyond is a hump of Earth curvature, as opposed to perspective or something optical.
I've never understood what Earth curvature is. Doesn't make any sense to me. Sounds like a misnomer.
They're basically saying a big hill is blocking what's beyond.
The big
Like a
hill
mountain
does have
or
a curve on it, though, doesn't it?
Yeah.
Is that what you would call Earth curve? A mountain?
A big mountain of Earth.
In the distance, so a mountain, when you look at the distance and you see a topographical horizon, you can go, there's a mountain there. That, to you, would be Earth curve, would it?
It would be like a big, round mountain. Relative to, what is it, chord? In their imagination.
I'm not talking about their imagination. Other people's imagination's a bit much. when you say Earth curve, would you say a mountain in the distance is Earth curve?
You'd have to specify what the mountain is in relation to. A mountain relative to the chord.
Shape,
Yeah.
a curve. Because, I mean, you said earlier that you're the type of person that has a flat not being flat, but you allowing for it to be called flat. Now, when you say Earth curve, do you look at a mountain and say, that is the curve of the Earth? It goes curve upwards, and then it gets to the peak, and then it curves downwards again. Is that what you would call Earth curve? Or would that be called like mountain
no.
curve?
No, like a mountain, no.
So that would be called mountain
would be
curve
like a
that
big
can be
mountain.
separated from Earth curve. So the
It would be a
visual
mountain.
curve of a mountain is not what you would call Earth curve.
No. A mountain by itself, no. A mountain on the top of the land, no. But it would be quote unquote a mountain relative to the chord of the Earth.
Right. So what
Curving upward.
is to you Earth curve? Can you define?
Earth curve would be going up the amount of land that's going up from some sort of chord, be it a diameter or a line going straight through the Earth. That's not the diameter.
The diameter is a straight line.
And you would have land curving up from that line, theoretically.
So go on. The curve would be from a straight line, curving upwards, like a mountain, per se.
Similar to a mountain in that it comes up from some sort of flat baseline.
So you would call a mountain Earth curve then?
No.
No. You're doing that nonsensical bit where you claim one thing and then take it back. Can you please be specific about what you are calling Earth curve? Is that the curve of Earth?
The amount of land curving up from a chord. A mountain is not curving up from a chord. It's curving up from the surface of the land. So we have at least two definitions here. The mountain that is on top of the surface and the mountain of Earth that's curving up from a supposed chord. So we have at least two things going on here.
Two different things, you're saying. So in order for you to have Earth curve, do you have to imagine a chord underneath a mountain to then conceptualize that mountain as Earth curve?
You would need to have something curving relative to a straight baseline. And the straight baseline for the globers would be the supposed chord going through the Earth.
Right, so they need a straight baseline. You're speaking for who? Because I thought I was asking you, what do you consider Earth curve?
This is where you start to play stupid, like you don't know what I'm talking about.
I'm trying to ask you, Lemon.
Out of a conversation.
Yeah, what do you imagine Earth curve is? Oh, Lemon's gone. Still never had a decent answer from anybody as to what Earth curve is. Doesn't seem to have any definition. It's just one of those things that nobody can know about. Yeah, I don't know what's going on. Why people come into state things that have no meaning. The elenchus is obviously a damaging thing. And it's a bit hard work for people to get a grip on. Go on. So I don't know what Earth curve is, or what anybody says. If you ask somebody what Earth curve is, I don't think they understand it, and that's why nobody has an answer. Because if you don't know what it is, then how do you measure it? If you can't speak about it, how do you know it's there? You don't even know what it is you're talking about. Going on about water. Right, I think we're done for tonight. It's been a grueling day. We've had Ruhith, Alpha, Jesse. It's been a good day. Been a good day. A lot of obfuscation. A lot of misunderstandings of different things. Hard work to understand what people are talking about. Still waiting to try and get a clarifier on what Rumpus's method is for doing his test. Whether people think the horizon should be above your eye level or below your eye level. Nobody even knows what eye level is. Doesn't really make any sense for anything. All right, okay. I guess we're going to end it for tonight. Try and come to some sort of reasoning tomorrow. It's Euclid Day tomorrow. Since we've gone over surveying and how you would measure an elevation change, might be a good idea to try and bring out a straight line test to give people a conceptualization of how we do it. Me and Spot On. The next level realizing Euclid straight line test. Make it as simple as possible talking about a straight line. Yes, we will use a water level. And that's it. Just a water level. I'll show you that tomorrow. Get on the whiteboard and do all of that sort of stuff. And I think big long Buster one. It's been good, and we're finishing a little bit early, so a long Buster lead out. So thank you very much. Join us tomorrow. I'm going to leave you with Gadget and Buster. Buster Live. Gadget drawing.
It's the echo in your brain. You know you can't sustain the misconceptions in your mind. One day you'll see for sure what all of this was for. Then you can leave it all behind. Reality starts here. We are the ones that take an active role. We are the ones here that are searching for the truth. We are the whispers of the logic in your mind. We are the agents of the Logos. In the beginning was found this thing that cannot speak. It's how we all truly learn. It's only ever attained when one lets go of fear. So don't let wisdom pass you by. Reality starts here. We are the ones that take an active role. We are the ones here that are searching for the truth. We are the whispers of the logic in your mind. We are the agents of the Logos. It was there all along. How could I never have seen this thing that's danced all around? It wasn't until I left behind the things I believed that I could see things so clear. Reality starts here. We are the ones that take an active role. We are the ones here that are searching for truth. We are the whispers of the logic in your mind. We are the agents of the Logos. We are the agents of the Logos. We are the agents of the Logos.
Wow. Bravo.
I gotta check. Oh, missed out. I totally botched this one up, but let's give it a go. It's true level bitch, but acoustic. So, I gotta change a couple things. There might be a little bit of fan in the background, but oh, this is good. I didn't realize this. Just found it out. Check this out. We are in a war that's in the mind for all to face. Choices will be made. You can choose to let your mind be free. You might think that you're right. Everybody knows that you're wrong. There are things in this world that are objectively true, but in the end you'll find we're all looking for the truth. We will watch it die
We will watch it all come tumbling down. We're tired of the lies, we're tired of the obfuscation now. You might think that you're right, everybody knows that you're wrong. There are things in this world that are objectively true, but in the end you'll find we're all looking for the truth. Let these shadows win, step into the light. We will not let these shadows win, step into the light. You might think that you're right, everybody knows that you're wrong. There are things in this world that are objectively true, but in the end you'll find we're all looking for the truth. And we will watch it burn, we will watch it all come tumbling down. From the ashes come something that is pure for all to see. You might think that you're right, everybody knows that you're wrong. There are things in this world that are objectively true, but in the end you'll find, in the end you'll find, yes, in the end you'll find we're all looking for the truth.
World's famous
just a
buster.
second. Yeah, here we go. This is this one's for Rikia. Is that coming through? All right. Move some stuff around. Here we go.
It's that nug life, baby. We deal with trolls gone crazy. We're all about that nug life, getting kicked from every server I know. We know these trolls are gonna lie and obfuscate for the show. It's that nug life, baby. We deal with trolls gone crazy. Water arrest lies evenly across the plain, and the Hydrostatic pressure is the answer that will end the game. We got the arguments and proofs to show. These crazy people gonna recognize the knowledge that flows. It's another life, baby. We deal with trolls going crazy. Logic and reality dictates that water levels don't curve, and that right line geometry dictates the 3D space of our world. We got the arguments and proofs to show. These crazy people gonna recognize the knowledge that flows. It's another life. It's another life.
All right, you want another one?
Oh yeah,
Yeah,
keep it
all right,
going.
here we go. Here we
All
go.
right.
I have enough confidence in the things that I know. I have enough wisdom to see the logic will be shown. I got one chance to show you what I've got. One chance to show if I'm logical or not. Self-evident reason, deductions and conclusions, and then the fools are running away. They're running away. It's not what you say, it's only what you can prove. You better watch your step, you better mind your P's and Q's. You got one chance to show me what you've got. One chance to show if you're logical or not. Self-evident reason, deductions and conclusions. We're logically thinking and the fools are running away. Caught in the matrix of all of these haters. Society spinning, and I'm just here living on the ground. You're flipping over backwards to show me where you think you are. Your model dictates that you never see too far. You got one chance, show me what you've got. One chance to show if you're logical or not. Shrinking in the distance, you can do fuck all with an angle, and the fools are running away. The fools are running away.
Done this one before, but it's brand new, and I just haven't got it recorded yet, so we'll just give it a go again.
writing on the wall, it's plain. The ramblings of these old men going insane. Now I see it so clear. They're running and they're hiding 'cause of fear. If I don't sing, if I don't speak out, if I never receive the Logos who will. If I don't sing, if I don't speak out, if I never communicate with logic who will. Transcendence of numbers and conceptual mass will take you on a journey down a Penrose path, and you'll never see it clear. The trail that you're on only ends in fear. If I don't sing, if I don't speak out, if I never receive the Logos who will. If I don't sing, if I don't speak out, if I never communicate with logic who will. Who will? Who will? Shadows step into light, taking down the giants and open sight. Now I see it clear. They're running and they're hiding, and it ends in tears. If I don't sing, if I don't speak out, if I never receive the Logos who will. If I don't sing, if I don't speak out, if I never communicate with logic who will. Taking back everything that was lost, taking back at any cost, taking back everything that was lost, taking back at any cost. If I don't sing, if I don't speak out, if I never receive the Logos who will. If I don't sing, if I don't speak out, if I never communicate with logic who will? Who will? Who will?
Ooh.
That song just gets better and better and better every
like
time you
that
sing
one,
it.
Man. Like it.
The favorite.
Go for it.
All right.
Wow.
Hopefully. All right, here we go. Is that too loud? Sound check.
That's what I mean.
Hey, Buster, if you know the words, can we sing along?
Yeah, I guess. You have to go on mute because there'll be like a delay. All right, here we go.
I got enough confidence in the things that I know. I got enough wisdom to see the logic will be shown. I got one chance to show you what I got. I got one chance to show if I'm logical or not. Self-evident reason, deductions and conclusions, and the fools are running away. It's not what you say, it's only what you can prove. You better watch your step, you better mind your P's and Q's. You got one chance to show me what you got. You got one chance to show if you're logical or not. Self-evident reason, deductions and conclusions, logically thinking, the fools are running away. The fools are running away. You're flipping over backwards to show me where you think you are. Your model dictates that you never see too far. You got a one chance to show me what you got. You got one chance to show if you're logical or not. Logically thinking, deductions and conclusions. You can do fuck all with an angle, and the fools are running away. The fools are running away, yeah.
Bravo.
I see the writing on the wall, it's plain. The ramblings of these old men going insane. And now I see it clear. They're running and they're hiding because of fear. If I don't sing, if I don't speak out, if I never communicate with logic, who will? If I don't sing, if I don't speak out, if I never receive the Logos, who will? Transcendental numbers and conceptual mass will take you on a journey down a Penrose path. And now I see it clear. The trail that you're on only ends in tears. If I don't sing, if I don't speak out, if I never communicate with logic, who will? If I don't sing, if I don't speak out, if I never receive the Logos, who will? Cast away the shadows and step into light, taking down the giants and opening sight. Now I see it clear. The trail that they're on only ends in fear. If I don't sing, if I don't speak out, if I never communicate with logic, who will? If I don't sing, if I don't speak out, if I never receive the Logos, who will? Who will? I'll take back everything that was lost. I'll take it back at any cost. I'm taking back everything that was lost. I'll take it back at any cost. If I don't sing, if I don't speak out, if I never communicate with logic, who will? If I don't sing, if I don't speak out, if I never receive the Logos, who will?
Man,